of Technology. Good morning to all. It is both a privilege and a delight to be here today as we gather for this prestigious international conference. Our gathering is graced by the presence of a truly remarkable individual, our esteemed keynote speaker, Dr. M.S. Jagadish Kumar, whose insights and expertise promise to inspire, educate, and elevate our conference experience. As we embark on this journey of intellectual exploration and collaboration, it is important to recognize the pivotal role that keynote speakers play in shaping the discourse and setting the tone for our discussions. Today, we are fortunate to have a speaker, Dr. M.S. Jagadish Kumar, who embodies the spirit of innovation and excellence. Dr. M.S. Jagadish Kumar is a head and professor in mathematics at School of Advanced Sciences, VIT, Vellore, India. He holds an MTech degree in atmospheric sciences and an MPhil degree in mathematics. He obtained a PhD degree in mathematics from the University of Kerala. He is a consultant for a leading multinational R&D organization and carried out many research projects. He delivered several talks at national, international conferences and workshops. He has association with various foreign universities as visiting professor China, Ethiopia, and etc. He won several awards, honors, and to list a few. Silver Medal Award for MTech, Cochin University of Science and Technology in 2001. MSMR, Senior Research Fellowship, Delhi. Professor Murthy Award, IIT Kharagpur. Honorable mention in USA. He serves as Research Fellow, ISRO Bangalore and ISRO Trivandrum. He is a life member of ISTE, ISTEM, and IMS. He was the Vice President and Acting Joint Secretary at IIT Kharagpur. He has published several publications in various reputed national and international journals. Today, we are privileged to have the speaker, Dr. M.S. Jagadish Kumar, who serves as a beacon of knowledge and who embodies his role with the unparalleled excellence. Our keynote speaker's journey and accomplishment are the testament to his dedication, passion, and relentless pursuit of excellence in his field. His insights have the potential to ignite creativity, stimulate innovation, and drive us toward the brighter and more promising future. Once again, on behalf of Icrtmcs 2023, I extend our heartfelt welcome to our distinguished keynote speaker, Dr. M.S. Jagadish Kumar. Thank you for gracing us with your presence and sharing your invaluable insights. Let us warmly welcome our keynote speaker to the stage with a round of applause. Over to you, sir.
Hello.
Thank you, ma'am. Dr. M.S. Jagadish Kumar, the stage is yours.
Respected Principal, Vice Principal, Organizing Secretary. Of this conference, Sister Santiago Teresa, all the speakers, Dr. Kasam A. Saleh, Dr. Anthony Xavier, Dr. Pir Basha, Dr. J. Sabaskar, and all other dignitaries, faculty colleagues, and my dear students. Very good morning. Of course, I thought that I'll first talk to you, then I'll come to my presentation. Since I didn't get a chance in the beginning, so let me address you 5 minutes. I'm standing this as a practicing mathematician. I use the word intentionally, practicing mathematicians, because you have heard the word practicing only with the doctors. They practice medicine after a registration. If they pass out from the medical college, then you have to get a registration with some oath, like I'll just do justice to this profession and with sincerity. But you can be a mathematician, just get a degree, start doing it, that's all. But we never practice mathematics. We learn, teach, understand, a lot of things we are doing. But I'm posing a question, why can't you become a practicing mathematician? Then there is a huge demand for that, huge demand for that. Because everyone around you want math. They want to learn, they want to understand, they want to improve their system. But still, the era is like we have a lot of technology, but still we are using maybe less than 5% of what math can do. Even less than 5% of math can do. Only maybe scientists, maybe some engineers, they are using the support of mathematics. But every field, you can do that. Now, I'm just taking you back to 1983. Something happened in India. Can you remember what it is? Yes, 1983, we won the World Cup cricket. It is not a small thing. It changed the fate of India. It united India because of this small game. That time it was new to us. Some people are playing game cricket. Then when we won first time World Cup, it come to the notice of all the people. Then everyone started playing. I was in 83, I was in school. So we started playing cricket because of Kapil Dev or Gavaskar or the people of that kind. Then everyone started playing, irrespective of city or village. Then we have talented people. We have a pool of talented people. Getting into Indian team is a big task now. So we have a wonderful team, a performer. After 40 years, one more thing has happened. That is in 2023, August 23. What is the importance? We have landed in moon, soft landing. 40 years after that. This again united India. We, all the scientists, all the engineers, all the people in this realm of knowledge, they unite together to understand, to explore how ISR has made this one. Up to that, ISR was here. I was in ISR for some time. I got a chance to interact with these people. I feel that that was the finest moment in my life. I know how these people are working, how serious they are, how dedicated they are. But you think about the journey where they have started. They started just with a small rocket, small piece of rocket, just which is available in shops now, kind of thing. Then they are simply test firing those things to collect data, then moving from place to place, understanding, simulating. Then they failed several times. The failure was more. That is why it came as a success now. Failure was more. We fire the rocket, it will not go to the destination. Several years, every Wednesday, we used to launch rocket, Rohini rocket. This is just a Sunday rocket, just to collect information from the atmosphere. It will go to several kilometers, collect the information, then we just keep it in magnetic tape. It is still kept in ISR and Space Physics Laboratory where I have worked. You know, we don't have this kind of sophisticated technologies to store information. Today, I'm going to talk about how to store information. We don't have sophisticated technology. We have just like in magnetic tape, we just copy information. One magnetic tape, you can just you cannot even copy the information what you are storing in a small pen drive. Like tons of magnetic tapes still kept in the storerooms of ISRO. Of course, they are not using it because they already coded those things and safeguarded it. I'm talking about technology was not developed to that extent. ISRO started working. Their first vehicle was a cycle. To transport things from place to place, it was a cycle. The rocket part they taking the cycle. You have seen this one, Dr. Abdul Kalam and team, and they sat in the greenery, then started discussing, not in AC rooms and all. Then why we are failing several times in all, when I was in school, all the mimicry and mono acts, one theme is about ISRO. Like they are launching their rocket, it's just going to Arabian Sea or Indian Ocean, like that. So lot of humiliation, lot of criticism. People started asking, why you are spending this much of amount? They are simply spoiling on 400 crores. What you are spending is not meaningful when people are starving. This was the question. But still people have the energy to proceed. And finally we succeed. So what we want is persistence and perseverance. Now today I'm very happy that I'm in a village where an institution is working and they are conducting their first conference. Like what has happened in 83, what has happened in 2023. Here, for you, at least this conference is very much important. This is going to change your fate. I'm sure about this one. This is going to change your fate. What is happening? At least 5 people get motivated out of this one. They gathered together. They started discussing. It will spread like a fire. It will spread like a fire and attract a lot of people. That will strengthen your program. So, and whatever amount you are spending, whatever the effort you are putting for this one, it become an added advantage for you. It will come back to you. So conference or gathering or discussions, whatever it may be, even the percentage of dissemination may be less, but it will make a difference. That changes the fate of the institution. That was what happened those days about cricket, about, the activities of ISRO, the soft landing, what has happened. But the target group is different. So I'm telling, like, you should understand what we are going to speak, not 100%. I'm going to speak a few things which came to my mind and what the new research area I have chosen. So try to understand it to your level. You may not get everything because you cannot learn everything within 1 hour. But try to understand what it is. Go explore. Keep on working on that. Like that. I attended my first conference in 2001 when I was in Cochin University of Science and Technology. I was sitting in the last row. I used to tell this one. I was sitting in the last row, but I was one of the organizers because day and night we are moving for this and that. Then we'll sit and enjoy what presentation is going on. But friend, if you sit in the front, everyone will listen to you. This is our tendency. Then when I was sitting there, people started talking about Indian monsoon, then talking about dynamics, fluid dynamics, some transport equation. So the particular talk, he was explaining the transport equation at different dimension. Then slowly I was sitting there, then I raised my head. After some time, I come and sit in front. Then I came friend. After the talk is over, I met the scientist. Then we have a interaction, the Professor Ramanathan. So we had a very deep interaction that kindled my interest on this one. That is why I choose my research topic as mathematical modeling. Otherwise, I got a fellowship in IIT Delhi for continuing my PhD in atmospheric science. I didn't join because of several reasons, but still I want to do my PhD in mathematical modeling. I struggled a lot for that, but finally I did it. Finally I did it because there was a consistent effort for that. I don't want to do in any other domain. You can publish a lot in certain domain, but still I have the satisfaction that I have learned something in that domain what we want. First of all, I want to be a mathematician. I want to be a mathematician. If today I'm asking, someone asks a question that what you are proud of, I'll say, I learned mathematics. Not just about my degree. My parents asked me to learn mathematics. I did it. I learned a lot of mathematics, not in terms of degree. Whatever you give, even my colleagues, you can see that. We are all proud of being a mathematician. Had I got an admission in computer science when computer science a lucrative subject in 1992. I lost the admission because there is high competition for that. I lost the admission for a few marks. I have a lot of, pain that time because of the reservation system and kind of thing. I didn't get admitted in first 14, only 14 seats in merit. That day I was thinking, oh, I lost this opportunity. But later when we started mathematics, started thinking about mathematics, today we are very proud of being a mathematician. I want to tell you that whatever your capacity of learning mathematics, every time you have to improve. There was an era that India has created a lot of mathematicians. Even the concepts created by this Ramanujan was still not understood correctly. There are a lot of undisclosed work still not proven, but which is true. So we are the part of this legacy. So definitely we want to do better. I am the head of the Department of Mathematics. So definitely, without talking about my department, this talk will not be complete. We have 133 member faculties in the Department of Mathematics. 133. Whenever I say there, sir, are you talking about number of students? No, I'm talking about number of students. Is it for the whole university? No, in my department. This 133 faculty members, all PhDs with outstanding publications, with very good credentials, with very good potential. We have published 548 publications in the past 5 years in Science Citation Index Extended. Altogether, 1,000 plus publication we had. So this has not just came. You should understand the way we are working. We are not just working for the sake of working, but we enjoy every moment in working as a group. I have my professor here who was part of my team. So you can ask him how we work. So I'm telling you that you love something, then you will not count for time and other things like that. Just love doing it, organizing, conducting, interacting. What do you get if you go at home and sleep? Nothing. What you get if you just explore in Facebook? You explore 5 minutes, 10 minutes, 1 hour, 25 hour, 10 hour, no problem. You define it, but it should not control you. You learn something, learn yourself, and enjoy the concept. I'm talking about not about university degrees, because I met one. I cannot call him as a professor. One researcher in the University of Kerala. He is a clerk. He used to come to our department, very simple dressed. So initially we were saying what this man is going to do here, because when you are in university, we feel that, oh, we have degrees, and at that time I was an FFL student. What is this clerical man who, to do this one? He gave a seminar. I still remember the seminar that is on magic squares. Magic squares. I have a great respect on him. He published several papers without a university degree. He published several papers in American Mathematical Society, in which I have not published even. Several papers he has published in American, because the order of work what he is doing is very, very potential. So anyone can do. You don't need a university degree for that. You don't need the support of anyone. Just love the concept. Start reading from the scratch, and follow your passion. How persistence and perseverance. One day you will success, like how this ISR has soft landed in moon. This percentage of failure was small, 90% failure chance. But ISR took all the options. Plan A, Plan B, Plan C, because this time we have to success. Recently, there was a meeting with NASA. Now NASA is asking the technology of ISRO. There was a time America has introduced sanction on our institutions. Now they are asking the technology, because to develop the same technology, they have to spend 2 lakh crore rupees. 1 year working capital, 2 lakh crore. It's a huge amount. But ISRO is spending total budget is 13,000 crores. Where is 13,000 crores and where is this one? That is the thing. We have a lot of talented people across us. You please understand, I'm coming from a place called Kollam. The ISRO director, he is Dr. Somanath. He studied in a small college called Tangal Kunji Musliar College of Engineering, TKM College of Engineering. One of the best college in India, I can say. But still I'm seeing from outside vicinity, it's a small college. It looks like a small college. It has not gone from that stage, but it has produced a lot of outstanding people. He used to come over there, and proudly, we are all associated. I didn't speak to him. I didn't see him also, but every time he used to come and see, he used to come to his alma mater with proud feeling that I learned the concept from there. So he grown from because of his persistence and perseverance. If you get some energy out of this conference, I'll be very happy. With these few words, let me get into my talk. I think this is working. Hello, can you hear me? Hello, can you hear me? Hello. Hello. Is it fine? Otherwise, I'll hold. Hello? Hello? Is it fine? So, this is my institution, the mascot of our institution. There are several buildings. If you find time, come as a team. You are always welcome. Yeah, my talk is on decomposition of matrices and its application. Let me tell why I chose this topic. I'm basically a fluid dynamist. I do solve fluid dynamics problem, model it, and get the output prediction on all those things. Particularly, I'm working in porous medium. You can see two things here. One is 5 plus root 5 by 2. The value is 1.618. What is the importance of this? This is called the golden ratio. Golden ratio. Why golden ratio is important? You read this one. You know about Galileo Galilei, who invented telescope. From here, he was watching moon and seeing the minute things of moon. When 500 years before, 500 or 600 years before, he has done this one. The great enthusiast, he told nature is written in the language of mathematics. If you ask mathematics, we say a lot. When you say a lot, that means you don't know anything. If you talk with clarity, you will not say a lot. You just specifically say the applications. This is, you see, nature. Nature is so beautiful. So beautiful. This ratio is kept in the universe. That's why nature is beautiful. Everywhere. I'm just telling he's very beautiful. He's very adonish. So meaning is all his proportion. This length by this breadth. If you just measure and find, it converges to this number, 1.618. This is Fibonacci sequence. You know about Fibonacci sequence? What is that? 1, 0, 1, 1. Then these two are added together. 2, then 3. Then sum is 5. 5 plus 3 is 8. This is Fibonacci sequence. Simply speaking, yn plus 1 is equal to yn plus 2. With the initial condition, this is initial condition. Yn is 0, yn plus n is 1. When you solve, you will get this answer. So this sequence, this you can represent in this way. And you see this ratio. Sorry, this is not solution, of course, or not the solution. When you take the ratio, what is the ratio? It will converge to this one. 1 by 1, 1, 2 by 1, sorry, 2 by 1. Sorry, 1 by 2. Like that, this ratio, when you take, it will converge to this one. Actually, this is the number, the sequence, the nature is built. For example, you take a sapling. You know about sapling. Okay. So first leaf will come. First no 0 leaves. Then 1 leaf will come. Another leaf will come. What the angle? One will come. Opposite side, nothing is there. Then another one will come. Totally 180 degrees. Sorry, 360 degrees. Then opposite side, 2 leaves will come. Then you can see 3 will come. Then 5 will come. You go and count. You can see that. Why it is so? Because of photosynthesis. Because the distribution of sunlight should be equal. All should get an opportunity to get the energy equally. That's why this distribution. So this kind of mathematics is embedded in all the phenomena in nature. Whatever you take, there is some mathematics embedded inside. This is one of the things. So we can identify. You just see a butterfly. How it is being designed. There are thousands of designs of butterflies. Beautiful. What is the measure of beauty? So everywhere some mathematical things are. You see the nature, the hills, the landscape. By default, for years, the landscape will come, which follows the mathematics. Only things you have to unveil. Pi. What is pi? It is circumference divided by. What is pi? Circumference of a circle divided by diameter. That is pi. That's a magic number. Because you cannot write that number in a paper. You can say only approximately. So the nature is built of lot of mathematics. And I'm just going to explore some mathematics behind the natural things. What is this? First mobile phone. I had a friend. He is very spendthrift. In 1980, 1991, he got a mobile phone of this. What is the cost? Approximately 3 lakhs that time. 3 lakhs that time. He sold the property and got this one. Because, and he hold like this in bus. He goes like that because the mobile this much, hold like this one. So everyone knows that he's rich. And you know, to make a call, 10 rupees, receiving is 10 rupees. And someone who's enemy, they will call for 20 minutes. Finish, your pocket is. So this was the technology initially we had. Then we improved to this one. This is again Motorola. The Nokia came into picture. You can see this one. What is this? Antenna. This antenna is much bigger. I cannot put this, so that's why I cut this figure. This antenna is smaller. Technology improved. This is much, mobile phone is much smaller. And then antenna is small. Screen is white. The screen, nothing. You simply, screen, it's not appearing here. When you put in your telephone, usual telephone, number will not come. That technology. Here it appeared. Whatever you type here, it will come here. Now antenna is inside. Antenna is there. It is inside. Small antenna, very powerful antenna. So antenna technology has improved. This one, again, digital display and all these things, much improved version. I'm not an expert to tell, but if I explore, I can say what is the difference between this model. So this is the evolution. This is the evolution. Everything, math inside. Math inside. You have heard Intel inside. Am I right? You heard Intel inside. Math inside. Otherwise, this will not have improved. Have you seen the face computer? Have you seen the face computer? It is much bigger than this room. If I just consider this a room with all the cubes and that kind of thing like that. Then chips. So thousands of chips inside a computer. The first kind of computer I was using, 286 model, it will take 5 minutes to switch on. We switch on and go and take a tea and come. That much time it take. Now you just switch on the mobile phone or sorry, your computer and start working. That's all. Even we are not happy. We are not happy. It's taking too much time, 5 seconds. I cannot tolerate. I want fraction of second. That's what I'm going for high rated computers and all. The amount you are spending, first time I used laptop in ISRO, it was 3 lakhs. Now laptop for even 20,000, 50,000. That's it. It is not the same laptop. That was capacity. Now it is very, we can say supercomputer of 80s. That kind of thing you are getting for 50,000 rupees. Technology improved just because of mathematics, not because of physics. Physics is there, definitely it is there. But all these things, size reduced. Physics plus mathematics, I can say. Okay, this again, small antenna. I don't know why this antenna has come, I don't know explanation, but something more. You see here, you can see a color screen. It is not painted. It can send color images. It can read color images and all. It's not a small shift. To get the face Nokia phone, I was in queue for 1 hour, nearly 1 hour in Trivandrum. Because Nokia first time introduced the color phone. To buy that 7,500 rupees. I didn't remember the number. To get this particular phone, I was in the queue for 1 hour, almost. Because there is a huge demand. Everyone wants a color phone. And that I had thrown after 2 years. Because the new phone came. Then after that, we have smartphone. Smartphone is different. Smartphone is a computer, which you can keep in the pocket. Previously, it is called laptop or something like that. Now it is pocket top, which turned as a mobile phone. So I'm just going to tell you what has happened. This is the latest iPhone. iPhone Pro Max. What's the price? Lakhs. Lakhs. So we have a dream to buy this. We won't buy. Even if you have money, we won't buy. Why should you spend? That's our attitude. Having a lot of features. But everything math inside, ultimately. See this one? This is a mobile phone. I'm sorry. This is a mobile phone. This one, you see? Antenna inside. How this transmits signals. How mobile phone works. You send some, you just have a conversation. That will be converted as electromagnetic waves. That will pass through some cables. Previously, just through a cable, some signals are going. Now, optical signals are going. What is optical signals? It will travel the speed of light. It is so fast. So, optical fiber technology came. Then we have a series of networks. Looks like a cell. That is why it is called cellular phone. Body cell, how it is arranged. The entire universe is arranged like cells. So, from shifting to one cell to another cell, mathematics support a lot. That's why we are able to succeed in this particular technology of mobile phone. Then you have a lot of, you have a chip inside. this sheet, it has the concept of Boolean algebra, correct? Otherwise, it will not work. And lot of math inside. And you have pixels, colors, and material. I'm going to talk about this today. What the pixel means, what the role of matrices, and what is the role of colors, how you create all these things like that. You are all using WhatsApp, correct? When do you start using? 2010 onwards? No, you are not born that time, is it? 2014, 15, we started using it. Now without WhatsApp, without Dosha, I can leave. But without WhatsApp, I cannot do. I'm not using flash drive and all. I just use WhatsApp because their server is very fast and kind of thing like that. Everything we use WhatsApp or Facebook or Insta. That's it. That's the way the technology has changed. But just because of mathematics. I'm talking about this part, but you can see that even you type something here. I'm just saying, how are you if I type? How it appears here? It is just numerical concepts. I mean, mathematical concepts. It will be, whatever you type, it becomes converted as code. That is called ASCII code, American Standard Code. So for each alphabet, there is a number. Whatever, for each character, there is a number. That number will be transmitted. Number means easily you can do that. You just take the binary form. That binary form you can convert as current, correct? 0 or 1. Then we just create bits and then you can convert. These are basic principles, you know. So a lot of other things. It can be even used as a calculator. I'm going to talk how this facility has improved. Because in WhatsApp, what you do, you can send a video. Have you imagined in 2011 how you send a video? You have to download the video, you have to attach with some mail. There is no mechanism to send it through mobile phones. And even color picture you cannot send. Picture you cannot send. Then how will you send color picture? So now we have any color picture, anything, simply you can send. Just because of the contribution of mathematics. You see, it's all about matrices. You know about this professor? He's a professor in MIT, Massachusetts Institute, a dream place. His name is Gilbert Stein. He is the professor who made this area popular. The domain of matrices, linear algebra, popular by Professor Gilbert Stein. Because up to that, we just discussed about linear algebraic theorems. Lot of theorems in the book. You know that in any classroom, teachers will come and teach theorems. They never say how to apply it. But he just made popular by telling the application. So we refer his books. Even I learned this concept referring his book. Linear algebra, Gilbert Stein, and David Seeley. I'll come to that later. This is a matrix. What is a matrix? You know what is a matrix. Teachers will come. Everything arranged in row and column. That's a matrix. But your understanding should be much better. I'll just tell in a different way. It is matrix. I can easily find out the height of P3, the weight of P4, if I arrange in row and column. But this is, suppose P1 is a person, you have thousands of information about a person, we can encrypt here. And for me, that is a vector. When I say a vector, you say a quantity having magnitude and direction. But for me, it is something like information encrypted from a particular individual. It may be a person, incident, whatever it may be, or institution. Is it? So this is one-dimensional. I write as a vector. This is row vector, sorry, column vector. So we write as a column, or you can represent as a point like this one. 1, 50, 4, 1. What is this? A point. You write a point. This is a point in fourth dimensional space. Or you can write second one, P2, 0.94030, etc. Ultimately, in n-dimensional space, you can map it. I'm sorry. Yeah. Now I want to speak about eigenvalues and eigenvectors, without which I cannot proceed. Basic concept. How many of you know eigenvalues and eigenvectors? Please raise your hand. The concept of eigenvalue and eigenvector. You cannot come to that one. Many processes I know. You please understand. We have an n by n matrix. We have lambda, a non-zero scalar. Then this equation, this is an equation. Ax is equal to lambda times x. What is that? Ax is equal to lambda times x. What is A? Is the matrix. So when you apply on this matrix, apply on this vector, that will be transferred as the same vector. X is a vector, like this one. When you apply, it becomes lambda times x. Not coming. Can you hear? Okay. Can you hear? Okay. That's fine. So, hello. Hello. Please. So this equation is very, very important. Let's say AX times AX is equal to lambda times X. That means X is transferred using a matrix and to get the same vector X. But lambda times X. You have a vector X. What is lambda times X? It is extended or shrink. Extended or shrink. So this says all the vectors which is magnified. Instead of extended, we say magnified. Okay, so that value is called, magnification value is called eigenvalue. And this vector is called eigenvector. What is the physical meaning of this? What exactly when you find a value, you see here, you have 1, 2, 3, 4, 5 points. This is my matrix. Please listen. This is my matrix. When I apply the transformation, the coordinate gets changed. It's a new transformation, new thing. So this is another axis. So this point, I have given the transformation here. 0, 0. If, for example, 9, 4, 4, 3, apply on this vector, multiplication vector, row with column, you will get these two formulae. When you substitute the values of P and Q, you will get these points. 0, 0 means 0, 0. 1, 0 means 9, 4. 0, 1 means 4, 3. 0, minus 1 means 4, minus 4, 3. All these points under this transformation, I plotted here. So I got this one. And if I plot all the points on the circle, I get all the points on this ellipse. This is a transformation. So first you have to understand what is the transformation. I'll explain in a better way. This minus 1, 2. What is minus 1, 2? X direction minus 1, Y direction 2. This is X direction 2, Y direction 1. So that point under this mapping transferred to these two vectors. You can calculate it here. So this vector is not changed. It is 1. Magnification factor is 1. But this vector changed to 11 times. 11 times. That is the eigenvalue. So if you solve the equation X is equal to lambda X, lambda is the factor of shrinking or expanding. So some vectors will not change under the transformation. And that magnification factor is lambda. The vector which will not change. After vector is not changed. This is the direction, this is the direction. But direction did not change, same direction. But it got magnified. This is very much required in image processing because image is a matrix. Image is a matrix. You want to enlarge. You want to shrink without changing the characteristic. A human picture you are taking and extending. Characteristics will not change. Your nose alone is expanding. Nothing else is expanding. How it look like? You lose the characteristic. So in image processing, in image compression, we want this concept of eigenvalue and eigenvector. Hope you understood this one. And there is a concept called diagonalization. Diagonalization. In diagonalization, what we do, we have a matrix. We apply transformation, some transformation, then you will get another matrix which is having only a diagonal element. That is the eigenvalue. So this process is called diagonalization. There are many techniques for that. One is similarity transformation, another one is orthogonal transformation. There are several theorems supporting this one. You won't understand everything. Try to understand a bit. So the theorem says, if A is a real symmetric matrix, real means elements are from real numbers, symmetric means A transpose is A. If A is a real symmetric matrix, then if you follow this process, find the eigenvalues, find the eigenvectors, put in the form of model matrix, then normalize it. Normalize means divide with the magnitude. Then N transpose AN will be a diagonal matrix. This is the process for diagonalization. This is applied everywhere. So you get a diagonal matrix. Diagonal matrix means diagonal entries are eigenvalues. That's why I say D. Lambda 1, lambda 2, lambda N. Then the problem is, now let me make it simple. I have an image. This image I will just make into some partitions we call pixels. So pixel means m by n matrix. If it is a square matrix, you can think about a transpose and all. A transpose is A kind of thing. But if it is not a square matrix, what you do? The answer is here. You won't do directly. You just go for A into A transpose and A transpose into A. What is A into A transpose? It's a A into A transpose is a symmetric matrix, correct? This A transpose into A is also a symmetric matrix. Then whatever process you have done in the previous stage, we repeat here. So you will get U as well as B. U as well as B. Then you write A in terms of U sigma B transpose. This is a beautiful decomposition. You will understand it later. A you can write in the form of U sigma B transpose. This U is a rotation. U is rotate image. There is some board. I have written something upside down. You cannot read it. You change it. That is a transformation. That is exactly a transformation. You rotate it. And it's too small. You extend it. That's it. You use a lens. That's what happening. Your image will be extended. You can read it. So linear transformation we are discussing about. Either rotation or stretching or compressing. So what is important about transformation? When you do transformation, you can easily understand things. That's all. Throughout our life, we are doing transformations. Even you writing some note, it's a transformation. Textbook, we are very difficult to understand. Your own language, you are transforming it. Is it? I'm talking about linear transformation. Line become line. That's it. You are rotating, line become line. You are extending, line become line. So it is linear transformation ultimately. So if you decompose A as U sigma B transpose, this U is the normalized model matrix of A into A transpose. B is the normalized model matrix of A transpose into A. This sigma, this is very important. This is compression or dilation. You are stretching it or you are shrinking it. It is embedded inside. So I'll just talk about this one. And I just talk about the rotation, you know, how to rotate something. XY is a point. We call it as a vector. So if you want to transform this, you see here theta rotation. This axis will become x dash. So you are rotating theta degree. So this is the rotation matrix. This is a standard thing. Cos theta minus sin theta, cos theta. So theta rotation, the point will change accordingly. You put this value of theta, multiply with x, the new xy will come. That's the meaning. You have old xy, a point. You put the value of theta, multiply it, you'll get the new point under this transformation. So this is about rotation. Now I'll speak about transformation. So far, you are seeing only numbers. You are thinking about materials. Very difficult to understand. Now only figures. You may be much more interested. See this one. What is this? Dog. Lab. Lab. Is it? Okay. Can we transform this image without losing the characteristic? I want to make a bigger. You are daily doing copying, pasting somewhere, extending, arranging with BPT and all. This is linear transformation. Okay. What is this? Horizontal stretching. You got an elongated dog. What about this one? Compression. Your dog is like this. Are you doing this kind of exercise? Yes. What about this one? Vertical stretching. What about this one? Vertical compression. Your dog look like this one. But the characteristic is not losing. When you compress a dog, you will not get a human. You can identify the features. So as an image, when you process, you should not lose it. What about this one? Rotating it. Anti-clockwise. I think your clock is running in this direction, not opposite direction. So you can rotate in any direction. Now you just forget about dog. I have a circle there. I want to get this image. Can you do this? What you are supposed to do? Easy. From here to here, it is easy. Do 1 plus 2 plus 3. What is 1? Horizontal stretching. Horizontal stretching. Forget about this, the last figure. I have stretched horizontally. This circle, I have stretched horizontally. Then vertical compression. From top, I just compressed it. Then rotation. So I got this one. So this is the way I reached to this figure. Is it clear? What about this? Problem is much complicated because I have more information. Information 1, information 2. This is called rank of a matrix. In classroom, you have studied rank. What is the rank of a matrix? Rank is the order of the highest order, non-zero, minor. Confusing. That's why you are struggling, failing the exam. But if you learn rank, the characters inside a collection of data is rank. So we are trying to form in the form of a matrix. There are two information. One is blue, another one is this one. I have a lot of other colors. That is a rank. Here rank is 2. If I make a matrix here, rank is 2. I am sure about this. I want to attain this one. Can anyone tell how to attain this one? Stretching, shrinking, vertical compression, rotating and all. How to achieve? Yes, this is the way. Is it 1 plus 2 plus 3? No. Because 1 is this one. Horizontal stretching, you will get this one. Then vertical compression, you will get this one. Clockwise rotation, you will get this one. Here, blue color is upside. Here it is downside. You did not get the image. Suppose I am with a blue dress and saffron pant, then it will upside down. Is it? So this operation, this is transformation. Is not the right transformation. Then what is the right transformation? This is the one. 1 plus 2 plus 3 plus 4. What is that? Clockwise rotation. This is the image. I just clockwise rotation I made. So that's why the clockwise rotation came like this. Next, horizontal stretching. Then vertical compression. Look at this. Use your own brain. Then clockwise rotation. So we came to the right image. Yes, similar image. If you do this much operations, then you will come this one. That is what you have seen. What you have seen previously. U, sigma, V transpose. U is rotation, right rotation. Sigma is all about stretching or compressing. Then V transpose, that is again rotation, different direction, suitable direction. But when you speak and talk like that, when you really want to do something, you have to apply math because precision is very, very important. What does this have to do with matrices? Sorry, film show is over. We are going to mathematics again. Lot of math. What is this? 3, 0, 4, 5 is a matrix. So 3, I'm taking 4 points. You forget about this. This is matrix. I'm taking 4 points in my plane. One is blue, red, green and saffron. Then PQ is point. When you multiply A with this vector V, this is column vector. You will get this one, this formula. Row with column operation, you will get this one. Suppose the point is 1, 0, you will get 3, 4. 0, 1 means you will get 0, 5. Minus 1, 0 means you will get minus 3, minus 4. 0, minus 1 means 0, minus 5. These points I mapped under this transform. This is the transformation matrix. Transformation matrix. So I will get these 4 points. I can map all the points here in the circle. I will get the ellipse. Yeah, exactly this one. I done only with these points, but if I consider all these points, this is the new shape I am getting. If I use this matrix is embedded with compression, rotation, all these things. We don't know. From this, we are taking out how much you have to compress, how much you have to dilate, how much you have to rotate, anti-clockwise, clockwise. All this information is inside. There was a time matrix is simple matrix for us. Now we know how much we have to do, how much you have to extend. When you do in computer, you are not doing it, you are simply stretching it, correct? You copy some image, just stretch from the corner. It's happening. It's happening because of this theoretical concept. What about this? This is about rotation. If you want the theta rotation, I already done this one. So cos theta minus sin theta cos theta. If this minus sign comes here, the rotation is opposite. This minus sign comes here, it becomes opposite rotation. Okay? That's it. Now you see, the sigma is called singular value. Singular value is the square root of eigenvalue. So that decides how much you have to extend. Singular eigenvalue decide how much it is magnified, how much it is shrink. Singular value design actually it is connected with the eigenvalue, but this is the singular value we say. Hence we apply a concept called singular value decomposition. I am talking about singular value decomposition now. So The sigma is the extent you are stretching in one direction. This is stretching in another direction. It will come in the diagonal. I talked about diagonalization. When you apply diagonalization, what you are getting is lambda. But when you apply this concept, you are getting sigma. Sigma is the amount you have to stretch. It's not like unknowingly you are stretching. When you do in your laptop, you can decide. When you are programming something, you have to tell. You stretch up to this one only exactly because you are writing algorithm. So you should know at what value you have to take decisions. So think about this image now. Sigma 1, sigma 2. It talk about extensions. Yeah, this thing, 1 second. We'll go to the next one. Yeah, here. All the things together. A is the matrix constituted of rotation, dilation, compression, and anti-clockwise rotation. What we have shown in figure previously. But same thing mathematically. So this matrix, this is the given matrix. Then this is U. This is rotation I told. This is sigma. This is sigma 1 is the one dilation. This may be compression. This is another rotation. U, sigma, B transpose. I'll tell you how to calculate that. I'm just now talking about singular value decomposition. Same thing already just mentioned. You have to split this matrix into U, sigma, B transpose. What is the process? Consider A into A transpose. Find the normalized model matrix U. Find the A transpose into A. Find the normalized model matrix. Find sigma and write in the capital sigma. Sigma means sigma 1, sigma 2, then put in this form. It is a diagonal matrix. All these things together, when you multiply, you will get A. So A is decomposed in this format. It is decomposed in this format. Okay. The same example, 1 second. I have done this computation as a small matrix. I have calculated normalized model matrix of A into A transpose. That is U. This is U. I have calculated normalized model matrix of A transpose into A. That is this one. I have calculated eigenvalues and put the root. It is this one. When I put these things together, when I multiply, I will get A. I am telling every time now, this one. This is nothing but rotation. Because cos theta, sin theta, minus sin theta, cos theta. When you can find theta, theta is minus 45 degree. When you put this as cos theta, sin theta, minus sin theta, cos theta, theta values minus 45 degree. So this part says you have to rotate the image. This part says you have to stretch to 3 root 5. This say you have to compress to root 5. 1 is the actual thing. If you less than 1 means compression. More than 1 means dilation, stretching. So this say root 5 times you have to stretch. This is again another rotation. I will come to the next stage. You see, this part is over. 3 root 5 times horizontal scaling. You have to extend this 3 root 5 times. This means root 5 times you have to extend. Not extend, actually compression. You see the next slide. Root 5 times. This means root 5 times. The previous figure, this figure, and this figure. There is difference, you know. There is difference because of this factor. Then see the next one. I'm coming to the first part, this one. So the angle I calculate, it is 71.72 degree. So if you rotate 71.72 degree, you will get exactly this figure. So mathematically, I know how much rotation, how much stretching, how much shrinking, all these things. This is very much important for computer science students as well as mathematics students. You should understand this. That's it. I'm talking about all this thing. First, we have rotation, then stretching, shrinking. Then we have another rotation. We'll come to this form. It's a collective form. Then there is another concept called dimensionality reduction. Dimensionality reduction. You know Indian flag. How many colors? Tricolor. if you don't see the chakra inside, because chakra has a different color. Only three color, the rank of the matrix, if you take these three, because rank means you just make the pixels, boxes, each box one color. So maximum three color is coming. So rank of the matrix is 3. If you have several colors, rank is several, sometimes 50, 100. It's very difficult to handle those things. If rank is less, you means only less information you have to transform. 3, if you want to send the Indian flag, it is easy. Tricolor you want to send, easy. Only 3 color you give the information, it will recreate the image there. So data processing is very simple. So that is the importance of dimensionality reduction. When you handle very huge data, you have to compress it. So if we want to store the data, you have to compress. I told that previously we are storing the information in floppy disk. Now we have digital sophisticated technology to compress it. That's why you are able to store 1 tera in small pen drive. 1 tera you can store in pen drive, small in, because of this kind of technology. I'm not talking about the technology is advanced. Much more things are there. That's behind it. Now you see, once again, what is this matrix? 1.8, correct? 1.2, 4.4, 4.6. What is the rank of this matrix? 2. Why? Because first row is not similar to second row. Whenever you multiply first row, you will not get the second row. If first row is a multiple of second row, we call rank is 1. This rank is 2. What about this one? 1.8, 1.2, 4.4, 4.6. I have done all the calculation. What is the calculation? I have decomposed, matrix decomposed. U, sigma, V transpose. You don't think about all these things. Understand you have to do some mathematical computation to split this A into U, sigma, V transpose. That is defined. You can refer book and do those things. But I'm telling like that time, this is what I am getting sigma. This is my sigma. Sigma consists of sigma 1 and sigma 2. You see sigma 1, that is dilation. I have to expand the image 6.71 times. What is this one? 0.44. That is vertical compression. Less than 1 means compression. So you are some point, less than 0.5 you are compressing. If you don't compress, what will happen? My image, you are compressing a little bit. If you are not compressing, what will happen? You don't get any additional feature. You can ignore it. So when this is very small, you can ignore it. If you ignore, then computation is somewhat less. You need only this one. This 0.44 compression you can avoid. So that's what I'm telling. Now you see, here I make 0. I make 0. Then when I make 0, something happened with this matrix. What is happening is, rank is 1. Now you see, 1.5, 1.5, 4.5, 4.5. First row is a duplication of second row. Or 3 times. When you multiply first row with 3, you will get the second row. That means second row is a multiple of first row. They mean they are dependent vectors. So I need to send only one information, my first row. Second row is a duplication. Correct? Ultimately, what is happening? This dilation, this compression is 0. So if you want to, I don't want to compress, means you start with this matrix. This is called dimensionality reduction. Because the previous matrix is this one. 1.8, 1.2, 4.4, 4.6. Suppose you have a 1000 by 1000 matrix. The rank is 1000. Rank is 1000. But by applying this technique, small change you are making, so your computation will be considerably less. But you will get the same image without much difference. Small things we are neglecting. So to get more accuracy, small accuracy, you have to do a lot of computation, lot of transmission facilities. So if you apply logical mathematics, then dimension of the data you can reduce. This is the importance of dimensionality reduction. So by applying the concept here, I got this matrix. So I instead of the previous matrix, I only need to use this matrix. There are several techniques of dimensionality reduction. Now currently I am working on this part. What is a better algorithm for dimensionality reduction? Without losing the features. With a better algorithm, how to send information. You heard about Chandrayaan. You enjoyed the photo. Chandrayaan, after this rover came out. 12 hours they kept it silent because there are lunar dust. When lunar dust came, he came and took photos. That photo came next day. A small photo came. It is just a photo, but it is a proud moment that we got a first photo from Chandrayaan, this moon. What is the importance of that photo? It is not, they explained in a news report, they explain it is not an easy thing to send. People are still thinking that time by time they will send it. To send one image of that kind, it took 6 hours because it is 3 lakhs kilometers. So that image, without losing its characteristic, with a limited facility, it should be sent to Hassan, where we have a center for receiving this one. Then you have to process the image. Only signals are coming, weak signals are coming. That weak signals we have to process. We have to extract all the information rank. The correct rank you have to take in. Then only you get a picture. Suppose it is a color image. It's not a color image. If it's a color image full of beautiful colors, it will take a lot of time. So you have to improve your technology. Even now, this is an open problem. Tomorrow you are coming with the technology that you can send the speed. You can send an image with the 3 hours, great contribution. You will be absorbed in ISRO. The one who is doing the computer program, who designed all these things in ISRO, is having only BSc qualification. Just BSc. He don't have an MTech, he don't have a PhD. He joined ISRO long back, all the brains, all the concepts, all the mathematics. The team is working, of course, but he is the brain behind that one. So if you have an idea, this lifelong this algorithm will be not in your name. So this kind of process, dimensionality reduction, new technique you can introduce, it's an open problem. It will save crores of rupees. This technology, if you go to NASA, their 2 crore annual expense will reduce to 1.77 crores, maybe, who knows? So technology matters. So this is rank 1 metrics, I mean. So in nutshell, this is rank 2 metrics. We reduce rank 1 metrics. But your data is huge. It is 10,000 by 10,000. When you reduce, it may be 50 by 50. I will explain it in a different way. Look at this. Can you see these values? 1, 2, 3, 4. What is this? -1, -2, -3. This, when I multiply this with -1, I got this one. That's why I put -1 here. 2. If you multiply first row with 2, you'll get this one. With the 10, when you multiply, you'll get this one. So all these are multiples of first row. Am I right? Second row is a multiple of first row. Third row is a multiple of first row. Fourth row is a multiple of first row. So I need to write only these two, the column and this row. So that is this column and this row. So instead of sending this matrix, I need to send only this information. Then you say you multiply and get the value. Suppose this is 10,000 by 10,000 matrix. Then you need only 10,000 plus 10,000. What is 10,000 plus 10,000? 20,000. You send 20,000 data. What is 10,000 to 10,000? Huge number, huge number. You don't need to send that much of information. To send that much of information, you have to pay. You have the bandwidth. You have time. Your computer will be. That's it. So instead of, because of this technique, this become rank 1 matrix. So you need to send only row and column information. It's just 8 number. So that way you'll save time. Suppose this is a different thing. What is the rank? This may be rank 1, 2, 3, 4 by 4. What is this one? I cannot write simply like this one. Previous case, in a single step I have written, but I cannot write now. What I do is, I write as a sum of 1 by 1 matrix. Rank 1 matrix. This is rank 1 matrix. Next one is rank 1 matrix. Here it is rank 1 matrix, correct? This is rank 1 matrix. So I wrote like this one. Similarly, if it is any matrix, you write it as a sum of rank 1 matrix plus rank 1 matrix plus rank 1 matrix. That is nothing but your U sigma V transpose. It is, when you expand that, it exactly comes like this one. It is a sum of rank 1 matrix. Some rank you don't need to send. Ignore it. Color is not important. I have a blue, which I have a small dot with a violet color, indigo color. What is the need I have to send the indigo color? You will notice that I will compromise. Reduce the, make it as 49. Like that, information which is not relevant, you have to suppress it. That's it. That is actually in practical cases, dimensionality reduction. Yes, this is what I told. Any matrix you write in terms of rank 1 matrix. This is rank 1, this is rank 1, and so on. That is nothing but this one. I told you sigma U, sigma V transpose. When you split row by column, it will come like this. This is sigma 1. This is the amount which you are enlarging. This is rotation. This is another rotation, part of that rotation. So when you split, it will come in this form of a matrix. So is some sigma, this is as a descending order. Large, medium, small, tiny. Last example I told. If the contribution of sigma 4 is very less, delete that. If the contribution is small, delete that. So you will get the image. That's it. This is applicable for transmitting the image as well as storing the image. So this is with a computation. Previously I just told it. Now this is a matrix. I computed U, I computed sigma, I computed V transpose. When I split a row with column operation, I'll get this one. This sigma, when you multiply this one, sigma 1 times, 21.2 times. Next one, 6.4 times, 4.9 times, 0.1 times. When you do this matrix multiplication, you'll get like this one. So this alone you take, this is the computation. When you completely calculate, this is the value. When you completely calculate, this is the value. When you add these things together, this is the value, not alone this one. If you take only this term, this is the values. If you take this plus term, this is the value. If you add this term, this is the value. If you add all the values, it is the same matrix. 3, 1, 4, 1. All this value, it is exact match. This is very close to this one. So we want only close values in image processing. That's it. I can spend another 5 minutes, 2 minutes. That's it. Suppose it is not a square matrix, not a problem. Because we are not bothered about square matrix and all. We simply think about A into A transpose and A transpose into A. Now I'm just talking about another 2-3 minutes I'll take. This is about image processing. You have some information, you have to compress it, you have to either store or you have to transmit. Then you have to retrieve it. You have to decompose it and you have to retrieve it. That's it. Now in actual image processing, what is happening? Image is a matrix. That matrix you just divide into rows and columns. Each row has some color. When if it is a black and white image, we say grayscale. Pure black is 1. Pure white is 0, or vice versa. A small shade of black is called grayscale. Like that, 256 grayscales are there. What is the importance of 256? 2 to the power of 8. 2 to the power of 8. So all these colors are marked with a 1, 2, 3, like that. So when you divide an image, you can give some number with that particular color. Just come here. Here. This is actually a digital image of a heart. If it's not continuous. So this is black, this is white, only 2 colors. So when I make in the form of a matrix, black become 1, white becomes 0. That's it. So I can just create this matrix. That whatever matrix are available, I just made this commute on U, sigma, V transpose. This is first computation. This is second computation. Third computation. You see clarity is only small amount is added. This is sigma 1 times U1, V1 transpose. Sigma 2 times U2, V2 transpose, like that. So here itself, most of the features are available. 4.74 is sigma 1 value. If you add these two strings together, you'll get a much more clarity. Here also clarity is not clear, but here it is clear. You see, I can stop at this stage. Yes, this sigma value is 0, sigma value is 0. Only this much computation I have to do. So that is about digital processing or compression, image compression. You see these 4 images. This is a well-known picture. Of course, I just took it from the net. This image I want to send. If I do rank 10, reducing to rank 10 means almost all the features I want. This image, not clarity. This is rank 50, reduction 50. So the somewhat clear, no? Almost all clear. Your budget is not good. Your facilities are less. You send this image, satisfied. You have more amount. People now you're depending on your customer. You send this image. This is 200, rank 200 image. So it's almost, but you see, it's not that clear even compared to this one. This is the actual image. This is rank 200 image. That's it. So that's the idea in general. And now, suppose you want a color image, what you do? I'm talking about grayscales, black and white image. If you want color, you know that color is consisted of blue, RGB, red, blue, green. So whatever M by N, you have to multiply with 3. And persistence of vision, continuous image means you have to multiply with 16. 16 image per second. You just imagine the amount of data. Every second you have to send this one. So the processing, if you are, unless otherwise you apply some good technique, your image, your transmission will not be smooth. Your amount involved with this one is more. So if you want to have optimum expense for this one, you have to apply math, better algorithm. Even now, you have this area domain has improved, but still people are searching for better algorithm. So there is a scope for research. Come with a new idea. It may be entirely different. You enter into this domain, come with a new idea and sell your idea. You will become millionaire. If you work in some institute, you will get some salary. Your salary will not cross more than 3 crores, whatever salary you are getting, mostly. But if you develop something $1 billion, you'll come with an overnight. It's not overnight effort, lifelong effort, but produce something good. Okay? All these concepts are available in these references. You can go through that and thoroughly read. Thank you so much. Focus on, in nutshell, focus on dimensionality reduction to improve the process, image processing and kind of thing. So thank you one and all again. Thank you.
Participants, any questions or any clarification? Thank you so much, sir, for your excellent presentation and for sharing your knowledge and expertise with us today.
Hello. So, thank you for the nice information. You told about matrix transformations. So, on the other way, we have bilinear transformations. Bilinear transformations in analytic functions. So, since you are working in transformations, I have the curiosity to ask, matrix transformation is the advantage over bilinear transformation?
That is a different idea.
Okay.
Because both way you can debate and you can come back to action. And also some domain you want to control and you convert actually.
Okay.
Some boundary. You
Yes.
want to transfer. So the best of my knowledge I'm talking about, you have a boundary, but it's very complicated boundary, so you cannot work.
Okay.
So you just transform to non-boundaries using a suitable transformation, but you want to convert the result in the original domain. So you can come back.
Okay.
You can come back to the actual boundaries and domain. That's a basic concept on bilinear transformation. Both
Okay.
way it will work. And multilinear transformation is also. I'm not that aware of this particular concept, but that still have a lot of contribution.
Okay. Sir.
Okay, thank you.
Thank you, sir.
That's a complex analysis.
Yeah. Thank you, sir.
Any further question? Thank you so much.
Thank you so much, sir, for your excellent presentation and for sharing your knowledge and expertise with us today.
We are truly honored by your presentation and presence. We humbly request you to stay on the podium as we would like to present the certificate and a gift to you. Thank you for sharing your expertise in the session.
From the year 1981 to 1984 and from 1985 to 1986. He obtained his PhD in electrical engineering from the University of Ottawa, Canada, 1986 to 1991. He was a part-time lecturer from 1986 to 1991 at the University of Ottawa, Department of Computer Science, Canada, where he taught senior level computer science courses in French. assistant professor from 1991 to 1992 at Concordia University, Department of Electrical and Computer Engineering, Montreal, Canada. Assistant professor from 1990 to 1996 and associate professor from 1996 to 2000 in the Department of Electrical and Computer Engineering, Kuwait University, Kuwait, and visiting research associate professor from 1998 to 1999 in the Department of Informatics and Operational Research at the University of Montreal and School of Information and Software Technology at the University of Ottawa. Associate professor from 2000 to 2002 and professor from 2000 to 2007 in the Department of Computer Science, American University of Sharjah, United Arab Emirates. He was a professor from 2007 till date in the Department of Information Science, College for Women, Kuwait University. Apart from the teaching experience, he was a coordinator of the computer science program at the AUS from 2000 to 2001. Founding chair of the Department of Computer Science from 2001 to 2003. Coordinator for ABET accreditation for the computer science program at the American University of Sharjah at AUS 2004 to 2005. Vice Dean of Planning and Technical Support, College for Women, Kuwait University from 2007 to till date. Acting Dean, College for Women, Kuwait University from 2008 till date. Chair of the Graduate Program Committee at the College for Women, Kuwait University, 2012. He was a Java Internet consultant at TouchNet Canada Consultancy for IBM and Toronto Real Estate Board from the year 1998 to 1999. Computer System Specialist at Bell Canada from 1985 to 1991. Software Design Engineer at Northern Telecom in the year 1984. He has presented many tutorials at conferences in the USA, Canada, Saudi Arabia, Singapore, and Jordan, invited seminars and keynote speeches in Canada. Member of the UAE Ministry of Higher Education Accreditation Team for Computer-Related Programs. Program Committee member at international conferences and editorial board member. Referee for journals, conferences, promotion cases, and research proposals, editorial advisory board of Computer Communication Journal, and editorial board of Journal of Communications and Journal of Software. Guest editor for special issues in the Journal of System and Software and Journal of Information and Software Technology and Computer Communication Journal. Master's and PhD thesis examiner in Canada, Kuwait, and the UAE. Supervised master's and doctorate student thesis and projects in Canada, Kuwait. Editor-in-Chief, Journal of Software Academy Publisher from 2008 to till today. He has published more than 130 journal and conference papers and one university textbook titled Software Engineering. He received more than 10 Best Papers awards at various conferences and seminars. He received a Distinguished Young Researcher Award in the year 1994 and a Distinguished Teacher Award in the year 1996 at the College of Engineering and Petroleum, Kuwait University. Indeed, it's a great pleasure and honor to welcome such a noble personality as our chief guest today. We appreciate you, sir, for your willingness to share your knowledge and expertise. Your presence truly elevates the quality and significance of this event. We are confident that everyone here will gain a lot from your presentation. Over to you, sir.
Thank you very much for the introduction. I am happy to be with a great audience in India. I never visited India before. Maybe next time I can make it physical. And I will be talking about the buzzword now is AI, but I will address it from the ethics point of view. And this is my second presentation on this topic. I did it a few months ago to our colleagues at the university which was attended by many colleagues from different colleges that have interest in AI and the ethics of AI. Before I start, as you know, the world now, especially in my area, the Middle East, is in big turbulence. I want you to share with me your prayers that God protect and save the people of Gaza who are really under very big pressure. And we hope that this will be resolved for the good of the region and for the good of the population, everybody to be living a honest and honorable and peaceful life. So what makes AI algorithms, and I put it between parentheses because the buzzword is AI and algorithms, but it is what makes systems ethical and trustworthy. So I'm going to address this issue of ethicality and trustworthiness because it is of concern to a large population of stakeholders, including consumers that are using such systems, researchers, practitioners, and definitely governments who are now getting involved heavily. The emergence of this issue of ethicality and trustworthiness is fueled by the great reliance and ever increasing reliance on AI and data analytics for making decisions, and we really want those decisions to be ethical, because most of those decisions, as we are going to see, they affect our lives. So we'll go through recent activities in this area, and I will address a couple of concerns, hopefully, before I conclude my presentation. So my work on ethics started about 10 years ago, where I started to teach a graduate course on ethics and professionalism, and from which I was contacted by people from hospital to provide staff and management training on medical ethics, because they felt that what I am offering to the graduate through the graduate course would be very useful for their professionals. The course that I was offering was for all graduate students, and most of the time I had medical students. So that's how I was very acquainted with medical ethics. Then I chaired the ethics research committee, and I have the link here. And we run a certificate free for anyone if they take the course with the videos there, and they do the test and they pass. So we provide certificates. So that is a service running in the university and is provided sometimes to outside. I also authored many papers earlier, and delivered a talk on trustworthiness of IT systems, and that was maybe about 20 years ago. I was very interested in the trust and trustworthiness of systems. I'll be starting to talk about people ethics versus system ethics. We'll talk about the ethical principles, and these are the one that I teach in medical ethics and in professional ethics. I call them people ethics because eventually I will talk about system ethics or AI ethics. We'll briefly introduce what is AI algorithm and what is AI applications. Talk about data ethics, very important aspect of AI ethics. And then how do we apply those ethical principles that were applied to people? How can we apply them to system ethics? And then I will link ethics and trustworthiness, and I will show that they are very closely related. And if you cover all the ethical principles, you would also be covering trustworthiness. So I'll mention this, and then I'll provide some conclusions and final thoughts. I'll be taking questions at the very end, and I'm sure the notes, the video will be available, and if notes need to be shared, I will not hesitate to share the presentation with you. Currently, a lot of books on ethics, many of those books I have read and I have used. For example, the book by Bina Amanath on trustworthy AI. I used it at the very end of my presentation to link trustworthiness with ethics of AI. I have read the other book on the ethical algorithm, a very nice book on the science of socially aware algorithm design. Very interesting book that I have with me. There is other books on responsible AI, trustworthy AI implementation, ethics of AI, case studies. So a lot of books now, and these most of those books are starting 2020. So they are all recent books on AI and ethics. IEEE was involved, is also involved in AI. They have a nice publication called Ethically Aligned Design. So they embed the ethics in the design and definitely the algorithm design. EU is also very involved in this, providing governance ideas, and they have a nice document on ethics guidelines for trustworthy AI. This is another document by the government in Dubai. They call it Smart Dubai, AI Ethics Principles and Guidelines. So as you see, a lot of work on the ethics of AI. First, let me talk about people ethics versus system ethics. In people ethics, human beings, ethics started very early in ancient history, started with the Greek philosophers, with the religions, and definitely one of the Greek philosopher, Aristotle, had worked on what we call virtue ethics. This is more like the moral ethics. What are the features of a virtuous person, a good person? So we call it virtue ethics. Then after this, for a long time, starting in the 1500s, we started to have other ethical theories. One is consequentialism, which is not a great theory. It says that the goal is very important. We don't care about the means as long as you reach a good goal. Now, so you can make people suffer, but at the end, as long as there is some benefit at the end, that is the idea, which is not was not very well accepted. And then we have the deontological ethics, which really talks more about the way of doing things. The way has to be ethical. For example, death penalty would not be acceptable because the way to punish is not acceptable. Consequentialism allows, for example, stuff like death penalty. And then comes principlism. This is where I am going to concentrate. This is very recent, about 20, 25 years ago. It started with two gentlemen, Beauchamp and his colleague, and they have developed the three principles for ethical behavior, from which medical ethics currently developed, and based on which, for example, in the state of Kuwait, the Ministry of Health the government has a law now for medical practice that really embeds the three principles of ethics that I'm going to talk about. In the principlism, we focus on individual behavior, close to the virtue ethics, but we also use it for good decision making. We call it ethical decision making. Now we know now are not alone. We have technology, and we are very heavily involved with technology. And technology started to challenge the society, challenge us. We know, for example, technology and social media affected a lot of behaviors in children and in adults. So it started with the use of algorithms that are embedded in the social media, which really started to control certain habits and certain aspects of our behaviors. We also need to consider trusting those systems, because now technology is used in decision making, is used in our social lives, for example, in driverless cars and medical diagnostics and etc. Can we trust those systems? So the issue of trust now is very important. And we really want to study the ethical implication by relying on those systems and how they impact our society. In people ethics, we are talking about moral principles that guide individual behavior and the decision-making capabilities of humans that should be based on good moral principles. People ethics involves understanding and adhering to moral standards that are universally accepted by society. Um, and in people ethics, we focus on individual responsibility, we focus on accountability of the individual, and we rely on the good character and good manners and behaviors of the human. Examples of people ethics include honesty, fairness, respect to others, and etc. Now, system ethics will focus on the social and ethical aspects and considerations that we need to consider when we design, when we develop, and when we use and interact with systems. So not only the use of systems, but also for the developers and for the sponsors of such systems, what is a good ethical system. Also, we want to see the impact of those systems and the interaction with those systems on the society. Examples of system ethics include the transparency of the system, the accountability of the system, in the algorithmic decision making. Also, how does it do with our privacy, safety? How about not discriminating? How about being secure in terms of confidentiality of our information and etc. So these are good behaviors of systems or ethical systems. Why do we need ethical systems, or why do we need system ethics? One, we need to first meet those challenges posed by technology. We need to provide a framework for understanding and addressing these challenges. How can we, from the different points of view and from a methodological point of view, so that it will enable us to make ethical decisions. So the ethical decisions, not only in the use, but also in the design. And this is what we are going to talk about, is the design of AI algorithms that are ethical. I should say also design, I may have a good ethical design, but when I implemented it, when I developed it, it may have changed. So it's not only the design, but also the implementation of the algorithm. So it's not bound to one phase of the development. And also the maintenance. So when we change an ethical system, we should not make it unethical. So the maintenance has to be also an ethical maintenance, in addition to the use of that system. Benefit is for everybody. We will have more responsible and accountable use of technology. We will be able to manage risks, to reduce harms to people and to the society. We align technology with societal values and goals that are definitely uh, for working for the well-being of humans, and it will increase system trustworthiness. And with system trustworthiness comes a lot of things, especially the economic benefit. I mean, if I trust, the more people trust the system, and the more the system has a reputation of being trustworthy, it will have more users, more customers. So it will affect positively the bottom line. Okay, what are those ethical principles? We call it principlism, and again, it started around 1998 with initial papers by Beauchamp, and it is now the guiding principles for medical ethics and general ethics. In addition to those principles, the three principles that were embedded in also the Belmont report. We have the Menlo report, which extended those three principles and adopted them to IT, because now we know because of the technology. So they added first they adopted them to IT systems, and they added the fourth principle, which is respect for laws and public interest. Uh, in individual ethics, there is no mention of public interest. Now here we added public interest, because in research related to, for example, social media and IT and other things related to IT, it affects the general population, like 5G research or 6G research coming. So all those, they really affect the public. Those principles, once they are understood and implemented, they provide a framework for evaluating and guiding our ethical decision making. And that applies to all fields, including healthcare, research, ethics, and technology, IT. And those principles can be used as a guide to evaluate the ethical implications of actions. So if I take an action, or I want to take a decision or a policy, or I want to adopt a technology, I can check how does it fit within those four principles. Does it respect people? Does it hurt them or harm them? Is it good for them? Is it fair, justice? Does it respect the law? And does it respect the public interest? So I can evaluate the implications. And they can also be used to resolve any conflict or ethical dilemma. For example, you may have a choice, for example, that may be good for respecting people or person, but then it may not be beneficial. For example, there is a famous case, which is an ethical dilemma that was resolved in the UK very recently, was related to blood transfusion for people that follow the Jehovah Witness faith. The parents are Jehovah Witness, and they don't allow blood transfusion. And they have a child, and they have this child needed blood transfusion. And here you have an ethical dilemma. Do you respect the person, because the parent has the control over the child? Do you respect their decision not to give blood, or do you go for being beneficent and non-maleficent to the child? The UK ruled it to be to go with the child, to go with the one principle against another principle, and that's what we call the ethical dilemma. Let me start with respect for persons. Respect for person is centered around people dignity, autonomy, and worth. treating people as independent individual, as autonomous individuals, that we should respect their opinion. In case of medical research, for example, we have to respect their decision. They may not want to participate. You cannot force them to participate. In medical ethics, for example, you cannot make an operation on a person without their consent. And that's a sign of respect. Uh, you can you want to treat with fairness, consideration, regardless of their differences or how do you do it? Informed consent. Informed means you have to tell people, you have to be transparent, telling them what you are doing or what you are intending to do. And then you have to explain it to them in a language that is understood by them. They don't have to be coerced or forced to take a yes decision. You cannot offer them a bribe or offer them a big compensation, because that would be not a truly legitimate consent. So it has to be a fully informed consent. And also by respecting their confidentiality, by preserving their privacy, by sharing the decision making with them, explaining the rationale for the decision, explaining the risks involved in this decision. So that is a sign of respect. In addition to respecting diversity, respecting, allowing fair accessibility to all people, regardless of disabilities and etc. That would be the implementation of respect for persons. For beneficence, non-maleficence, in medical ethics, some people split this principle into two: beneficence as one and non-maleficence as another one. They really complement each other. Beneficence means do good, and non-maleficence means do no harm. Okay, so you do good and you avoid doing harm. Okay, so this principle requires individual to act in ways that promote their well-being, be good to them, avoid harm, involve the duty to do good, the duty to prevent and avoid causing harm, and to promote always positive outcomes to society and to individuals. How do you do it? By being very careful, by acting in due diligence and due care. Look at the details, read between the lines so that you avoid any mistakes and you always do good. Provide accuracy in your judgment, in your analysis, in your decision, effectiveness, and then robustness. Because if you are doing something, if your decision is not robust, it's going to collapse, or it may have side effects that are not desirable. How do you do it? Also by doing proper risk management. You know, if I want to take a decision, let's do risk management to see what are the risks involved in this decision. If I want to make an operation, let's do risk management. So if I want to fabricate a new medicine or a new drug, I should do risk management. And risk management is heavy in pharmaceutical, in security, in banking. It's also part of due diligence. Okay, the aim is to maximize the benefit and minimize the harm. If you identify a risk, that's fine, but as long as you mitigate this risk or you deal with this risk, that would be acceptable. And as long as you tell the people about the risks, to show respect for them, because they may decide not to go through this operation based on the risk, or they may decide not to participate in this research based on their perception of the risk. It also involves physical safety. Make sure that the environment is safe, whether for medical research or for any kind of operation that you are running, banking, education, all sorts of operation. The other one is online safety, data protection is related to online safety. The third principle, justice, is about treating individuals fairly and equitably. And that similar cases should be treated in a similar way. So that is justice. Now, I'm not going to go in details the difference between equitably and equally, because we don't want to treat equally because that may not be ethical. We want to treat equitably. Okay, so equitably has the idea of proportionally, so that you are equal representation. So that is equitability. Okay, how? By fairness in the distribution of benefits and in the allocation of resources. That's clear in medical ethics, for example. You want to have medical services to poor and to rich people, not only to rich but to also poor. Elimination of disparities and discrimination, and also universal accessibility. That is to implement the justice principle. Let me switch to system and software. So I talked about the three principles in terms of people ethics. Now I want to switch to system ethics, and especially AI systems. When I talk about system, I'm talking about one component of, sorry, when I talk about systems, I'm talking about different components. One of them is software and people. I talked about people and data and information. The other components are hardware and procedures. So this is a well-known definition of the components of a system. People, hardware, software, data, and procedures. I'm zooming into software, and software is really based on an algorithm, and that algorithm works on data, process the data, and produce some results. So when we talk about software, I'm talking really about an algorithm that is designed and implemented. And when I talk about an AI system, looking at software, this is the AI software, and specifically the algorithm that is implemented in this software. So when I say trustworthiness of an AI algorithm, we hope that it is leading to a trustworthy and ethical AI system. I mentioned earlier that even if I have a good algorithm, if my implementation of the algorithm is not good, that's useless. I mean, I will have a bad system. So we hope that if you have a good algorithm, you follow it up to a good implementation of the algorithm and a good testing of the implementation, so that you have finally a good deployable system that is carrying the good characteristics of the algorithm itself. Okay. AI algorithm exists now in many domains. The most recent domain is NLP, natural language processing. This is where large language models exist. We all know now of ChatGPT, which is under large language models, under the NLP kind of algorithms or domain of algorithms, natural language processing, in which you also have translation and all those things related to processing languages, where AI algorithms are heavy. Healthcare application, education, customizable education. We use it in other domains like cybersecurity. We use it in law enforcement, profiling at the airports of the travelers. That's law enforcement. So a lot of applications of domains of applications of AI algorithms. The typical algorithms that exist, for example, image and video recognition. There is big controversy about image recognition and video recognition, especially because these things can be faked. Medical diagnostics in medical applications, personalized learning, in education, adaptive testing. We use it a lot now in in the testing of students, right? Autonomous vehicle is another application where AI is heavily involved. So as you see, they really touch our lives. I mean, they touch our daily lives. So if you take your 24 hours a day, you see you are heavily involved in those things and you are affected by those things. When we talk about algorithm, we often, when I say ethical algorithm or ethical or trustworthy algorithm, we should not underestimate data. You know, those algorithms, they work with data. You know, we have data analytics, so we analyze the data. Now we should really put an emphasis on the data themselves. So the ethics of algorithms sometimes depends greatly on the data it processes or it learns from. For example, if you are learning from bad data or biased data, your learning is wrong. Your decisions are going to be based on bad data. So the outcome will be not correct. So there are a lot of risks associated with using data. So we have to be careful in avoiding those risks, avoiding the risk of having biased data. Okay. Uh, if you don't collect data equitably, you may end up with biased data. If you don't collect data to represent truly the population, for example, you may make decisions for the whole population that do not fit the population in the average. They may fit a certain portion of the population. That would be a biased due to biased data. Risk to data in terms of confidentiality, data security, in terms of confidentiality, integrity, and availability of the data. So data is very important. If you rely on data to make decisions, you want to make sure that the data is modified in legal ways. You don't want an attacker to go and change your data without you know about it. So if someone changes your data, tamper with your data, you will end up using your data to provide the wrong decisions. Privacy violation risks, accuracy risk. Overfitting is a kind of accuracy risk where you learn from a small or limited population, and then you try to fit it to a larger population, and you will end up with lots of bad decisions. Lack of transparency. We have data, we collect it without consent, we collect it without telling people about the real purpose of the data. So you have to be very careful when someone gives you data to analyze it in your algorithm for testing. You have to question about those things. Is this data not biased? Is it obtained ethically? Was there a consent from the owner, from the data elements that represent people sometimes, like health data? Okay, so you have to make sure that this data is very important. So I cannot talk about algorithm ethics without talking about data ethics. Okay. How do we mitigate the data-related risk in AI algorithms? Definitely by using now standards, by doing proper data governance to ensure the privacy, the security. So we have, for example, the European Union, they have GDPR, which is a very important framework for data governance. You have ISO standards for data governance. In the medical field, we have HIPAA, which is an act in the US to deal with health information, Health Information Protection Act. We have to be able to assess the quality of the data, and we have to be able to clean the data if needed. For example, get rid of noise in the data, get rid of get rid of um, outliers in the data. We have to be able to find ways to detect the bias and mitigate the bias. We need to do some robustness testing on the data. We need to make sure that the data is easily explainable. We know what is this data about, how it was obtained, was there a consent to obtain it, and definitely part of governance is to do regular audits on my data, make sure that no one has tampered with, that it is still confidential and is obtained legally. Now, I want to go quickly over this because it looks like I don't want. How much time do I have left? If anyone can tell me. I think I will need another 20 minutes at least. Anyway, so what I want to talk about, how can we do AI system or algorithm that is ethical according to the three principles? So uh, if you give me an AI algorithm, I want to uh, uh, assess it according to the three principles. Remember, we can assess any decision, any action, any policy, any adoption of any tool. For example, here we have the AI system. I want to assess it against those three principles: respect for person, beneficence, non-maleficence, and being just. In terms of AI algorithm to respect persons, I want still the informed consent. If you want me to use an AI system, I want to make sure that I consented to the data that this AI system is using. I want to make sure that the data you collected through this system and you are manipulating through this system, that is protected, that my privacy is preserved, and my confidentiality of the information is there. Explainability and transparency, and so I want you to explain to me the data, why are you using it, and not only and how you are going to process it. Now, some people here say, and that is in opposition from developers of AI software, they refuse to show you the algorithm. Now, how do you do this? And now, this is the role of governance. EU, for example, and other governments like in New Zealand is pioneer also in ethical algorithm. They are asking anyone that is developing AI software or AI algorithms to publish it, and so that allow practitioners, allow theoreticians or academicians to look at the algorithm and criticize it from different points of view. Is it explainable? Is it transparent? And so this is the need for human oversight. We need someone to examine those systems to see whether they respect people. So there is a need for governance and for human oversight over machines. You know, a system, after all, is a machine, or is not a human being. Here I talk about each one separately. I already mentioned those. What do I mean by oversight, by respect for person? To achieve respect, to achieve respect for person. The second one is, how can an AI algorithm be beneficent and non-maleficent? So we want to make sure that the system that we are going to develop provide accurate outcomes and is robust, is not going to fail. If I am doing telemedicine and I'm doing a teleoperation, I want robustness because I want the robot that is doing to not to fail during the operation. So that is robustness of the AI system. And robustness, the more robust, the more safe, the more non-maleficent. It's not going to harm the users. So safety, robustness, accuracy, preciseness, they are all related to being good or do no harm. Privacy preservation, transparency, and explainability with respect to being good, being accessible, and avoiding bias and discrimination because that's doing bad things, And again, here we need human oversight. So we really need human oversight to ensure that our AI system is not hurting and is doing good. And here I go through each one of them. I don't have time to go into each one, but I briefly described it. The last principle, which is justice. How can an AI algorithm be just, be fair, be unbiased? I mentioned data. First, you may be you may not be fair, you may not be biased, unbiased because of the data. So we want to make sure that we can detect data bias, and we can somehow correct by eliminating, by cleaning the data, by filtering the data. So we need to do cleaning and avoiding bias in data. We need to be transparent, because being transparent in many aspects it means you are fair. So if you want to be fair, be transparent. Don't hide things. Tell the truth. Okay. We need to provide some fairness metrics. What do I mean here is, as a result of using the AI system that touches, for example, humans, you can develop some metrics related to coverage or to inclusiveness. For example, giving loans to bank customers. If you are discriminating, it will show in the metrics. It shows, for example, that you are giving only 1% of loans to, let's say, I'm just giving an example, to black customers, and 99% of the loans go to white customers. So that is going to be noticed over time by observing those metrics. Think of them as key performance KPIs, but related to fairness. Okay. So it may be to avoid discrimination, to make sure that you have equitability, and etc. Again, human oversight to make sure that the system is just. Make sure that you have representativeness that will achieve also inclusiveness, and you are not discriminating against part of the society. So make sure that this does not exist in the algorithm itself. And this is what we call algorithmic accountability, which means that any decision made here, although it is made in an algorithm, but it is finally a human decision. Someone has to be responsible and accountable for the algorithm. Okay. I know, for example, Facebook once uh, they 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 had an algorithm that can the way they designed it, they can have an influence on your brain function, and they say it. And because of pressure from the academicians and everything, they had to remove this algorithm because it was clearly not good for people. And so, because it affects their cognitive decision making power, they make them they become addicted, and and so addiction is making you addicted to, for example, watching being on Facebook is not good. Addiction in general is not good. And I go through each one of them. I'll leave it for okay, I'll talk about two examples of algorithmic bad algorithms or unethical algorithm. One is the concept of fairness gerrymandering, which is known in the field of data ethics and AI ethics. And the other one is fairness and and the other one I'll talk about is statistical parity and fairness. So there are many techniques that you can use and that you can adopt. For example, differential privacy is good. I will leave it. I don't have time to go over, but I'll talk about two of them. Fairness gerrymandering. This picture is taken from the book about the ethics of algorithm that I read. For example, you have two populations, circle and square. Think of it as uh, um, two different populations, but there is male and female. Now, it looks fair to the two different populations. You have the same number of black square as number of black circles. Now here it means that you have equal distribution between circle and square, but it is not equitable. Equitability here means you have to cover proportionally. Now here you have female are not represented in this among the circle population, and males are not represented among the square population. So if you look in at the big picture, it shows it looks like it is fair, but when you look at the equitability aspect, you could see that it is not equitable. What you should have, if male are equal to female, then you should have the number of black circles distributed among male and female to be representative, and the same for black square. So that is what we call fairness gerrymandering, claiming that you are fair, but in practice you are not fair. You discriminated against female in one population and against the male in another population. Okay, so that's fairness gerrymandering. The other one is called statistical parity in algorithmic fairness. For example, you are in a bank and you want to give loans, right? And you know that in your population there are people that are applying, but based on AI, you know that they are not going to repay. Okay, so and others they are going to pay. For example, in the left hand side circle, you could see and if you want to be fair 50-50, it looks like you have 30% repaying circle. Those are, think of them as population that are middle class or high class, and the square population is the maybe let's say less than middle class, and so the repaying is only 15%, and otherwise and the other side is 30%. If you want to be fair, and your definition of fairness is to cover both classes of people, then you either have to give 15% of the repaying square and 15% of the repaying circle, and depriving the other 15%. You are going to deprive 15% of the repaying of the circles because you want it to be fair, 15% in each. Or if you give 30%, it means you are taking higher risk as a bank, and you are giving to 30%, knowing that only half of them will have the capacity to repay you. So here you are under a dilemma. Do you are you going to be fair to the repaying one, or you want to be fair to the repaying circles, or to the repaying square? Okay, so that's based on statistical parity and algorithmic fairness. Again, it really you, the designer of the algorithm, who has to take the decision and has to be accountable for it. Okay, so that is another aspect that is to take to be considered, and that when you look at algorithms, you have to examine those things. So it's like you have to have a checklist of things that you want to avoid in your algorithm, and this is a challenge because you need the people that are trained to check those things. The last thing I want to talk about is mapping those principles to trustworthiness. And here I used the book by Bina, AI, Trustworthy AI. In her book, she defines trustworthiness as 9 features: fair and impartial, privacy preserving, robust and reliable, transparent, explainable, secure, safe, accountable, and responsible. Although responsible here covers all, responsible means you have to be acting in due diligence and due care in terms of being fair, being secure, safe, and etc. So when we look at those trustworthiness requirement, the 9 requirements, and you try to find where are they covered, and you find that they are all covered in the 3 principles of uh, of the ethical principles. So you could see, for example, robustness and the reliability really is part of being beneficent, doing no harm, and doing good, avoiding harm and doing good. For example, security falls under respecting persons and do no harm, because you want to eliminate the risk of losing confidentiality and privacy. Safety is doing no harm, beneficence. Um, and accountability is being just, fairness and impartiality being just, and as I mentioned, being responsible means you are acting in a way that you are respecting people, you are not doing harm, and you are just and fair. So what I want to claim here is, if you are ethical, you are also trustworthy. Okay, and in life, think of it, the more the if you have a reputation of being an ethical person, people will come to you, people will seek your services, people will seek your advice, people will trust you. Okay, so so being trustworthy is being ethical. So if you go over the principles, and you use those principles to guide you in the decision making, and to force those principles on any AI algorithm or AI system, first, your system will be ethical, behaving ethically, and people will trust it. My conclusions and final thought on this: we really need to regulate the design and use of AI algorithm. This is an area where we cannot leave it to companies to make money at the account of the health of people or the well-being of people. It has to be regulated. There should be governance. There should be laws, regulations to hold any developer of AI systems to be accountable. I also stressed that we really need data ethics. We need to collect the data in an ethical way. We need to manage the data in an ethical way, okay? So that we can trust the data, and therefore we can trust the algorithm that is processing this data, because the outcome of the algorithm is a decision, most probably, and that decision has to be proper decision, ethical decision based on ethical data. Governance for data, so, and the AI system. Now I know, for example, there is an AI risk management framework for in NIST. There is a lot of work on data ethics for AI and governance for AI related to data. The importance of human oversight, very important. As you see, we cannot leave the machine without human oversight. We need to audit those machines. We need to audit the outcomes and decisions made by those machines. And the last important thing, which is a concern to educators and to academicians, is to really help in training skilled professionals to ensure what I talked about. I mean, to audit, to assess, to evaluate, to test those systems against the principles or against the elements of trustworthiness. Now, you may say, well, educators also need to educate themselves. I mean, this is what I did myself. I have developed my skills in ethics, and I used it to extend it to AI ethics, and and it's a continuous learning process. And definitely, in my situation, I'm teaching those things to my students, graduate students, through thesis and through courses. That's my concluding points, and I'll be happy to entertain any questions if time allows. And I leave the floor to the manager of this talk, and please let me know if you have any questions. Any question?
Dear past participants, if there is any queries, the forum is open for you. Please, you can ask your queries. Yes, sir. There is one question, sir. Yes.
Okay.
Good afternoon, sir.
Good afternoon.
Thank you for your innovative presentation. I have one doubt in artificial intelligence.
Okay.
What jobs will not replaced by artificial intelligence?
What jobs will not be replaced by artificial intelligence? Any job that require innovation, critical thinking, auditing, assessment, and there are other jobs. I mean, but in terms of people that are in IT and in the arts, there is always the jobs that require human touch, human oversight. You cannot leave things to the machines. Definitely, there are jobs that where the human will have control over the machine. But for example, uh, let's take lawyers. You still will need lawyers, but not as many as what we have now. Doctors, we still need doctors, but not in, for example, in the clinics, maybe in the operation room, right? So we cannot get rid of the those professions that are heavily involved in human decision and human oversight. Other question?
Afternoon, sir.
Yes.
Could you please tell me about what is the role of natural science in artificial intelligence?
Natural science. Can you repeat the role of?
Could you please explain about the role of information science in artificial intelligence?
Information science. Well, information science is a big area that involves information. And as I mentioned, data information is the fuel. You can fuel any AI. You cannot have an AI application without data. And this is a challenge, is you need to have data that is collected ethically, processed ethically, maintained ethically. What do I mean by maintaining the data? That the data has to be secure. No one should be allowed to change in any way they like. It has to be controlled, and that's why we need data governance. So in the area in my department, Department of Information Science, it's basically information system, but under the area of information science. But information science is a big umbrella. that involves a lot of aspects of information processing. Okay.
I have a one question.
Okay.
Suppose many are from mathematics background.
Yes.
Suppose if you want to learn artificial intelligence
Yes.
in website through website, uh, can you suggest a better online tool?
To
Or web
learn
page?
AI. Hello. Um,
Yes,
you
sir.
know,
Yes.
yeah, to learn, if you have a strong statistics background within mathematics, that would be an addition. I mean, any now machine learning algorithm relies on a strong statistical background. Uh, what you really need is to, in addition to the statistics background, you need some elements of programming and dealing with tools. Again, depending on which area you want, if it is it an LP, is it vision, robotics. So they have, and that would be advanced tools for machine learning. But there are a lot of free websites, free online courses that can help you in this. I mean, a lot. And I don't have in my mind, but I went through IBM training. I think Coursera. Coursera has a sequence of 9 courses that really goes through tools and through statistics, uh, like, and these are about 4 weeks courses each. So yes, you have a lot of options there. And this area I talked about is, it's a new area. Like how do you, what can we have? I mentioned checking the ethicality of algorithm. Can we have tools to do this? We don't. We have 1 or 2 tools. I didn't mention them, but this area is new. Okay, is how do we do check those aspects of transparency, of fairness, of this and that and that. So that will be very useful for auditors and for people who are assessing and governing those algorithms. So you need people, and I mentioned that we need skilled professionals to do this. That's an emerging thing. Now, ethics is very important. Any new technology, you can use it ethically and you can abuse it. You can use it unethically. We know, for example, for a fact, the Nobel in Sweden, when he invented the dynamite, uh, he never thought of being used to kill for people to kill each other, right? It was used to open roads inside mountains, and then people used it for in bad things. So that's why AI is good, but why do we need to intervene as humans immediately? Is because it may be abused, and you want to avoid this. So by providing guidance and governance on how to make sure that AI systems are not going to be done to abuse people. I mean, I mentioned AI in security in the airports. Okay, you go to the airport, they say, well, go to the uh, they pick you for extra questioning and checking, right? And when you ask why, they say it's not. We don't know. I mean, the program chose you. Now, for me, I would like to know why did it choose me? What are the criteria Was it fair in their choice? Did it discriminate against me? Is it because of my origin, by my? Is it because because they may know even about your salary? So is it because I'm poor, right? So I'm not talking about whether you are ethnically from this area or no, but maybe even your salary may be working against you, and you may be picked for that. In a bank, when you go to take a loan, they may use the address where you are living, and they may say, well, you live in a poor area, therefore you may not pay back the loan. So they discriminate against you, and you never know. There may be 100 pieces of data about you. Okay. Now, how did they get this data? Did you consent to give them this data? So again, a lot of issues related to the use of data and of AI systems. Okay. Any question?
No questions, sir.
Thank you.
Thank you so
Thank,
much, sir, for sharing your insights and vast knowledge on what
thank
makes artificial intelligence algorithm ethical and trustworthy. This topic was an off topic for today's era. It was mind-flowing and enlightening. Thank you so much, sir.
Thank you. My pleasure, and wish you all the best and good luck to everybody. And I hope you benefit from this talk. It opened new maybe ideas for you to learn about and to expand your knowledge and be hopefully everybody useful to our society. Thank you very much.
Definitely.
Thank you.
Thank you, sir.
Let's move on the second session of the day by the keynote speaker, Dr. Anthony Xavier, Head of the Department of Mathematics, Loyola College, Chennai. I call upon Ms. Alirani, Department of Computer Application, to introduce the speaker, Dr. Anthony Xavier.
We would like to welcome our second keynote speaker, Dr. Anthony Xavier, Head, Department of Mathematics, Loyola College, Chennai. We thank you, sir, for accepting our invitation and being here with us to enlighten with your wisdom, knowledge, and expertise. He completed his UG Mathematics in the year 1992 at Government Arts College, Krishnagiri, University of Madras. PG Mathematics in 1994 at St. Xavier's College, Manonmaniam Sundaranar University. In 1995, MPhil at Loyola College, Chennai. And in 2020, PhD at Loyola College, University of Madras, Chennai. He has teaching experience of 25 years in graduate level and postgraduate level for 19 years with dedication and commitment to his assignment. He had been a core member of LIMCOS from 2017 to 2018. He has a research experience for 11 years on the topic of graph theory and theoretical computer science. He has guided almost 11 PhD students and 6 students are pursuing right now. He has published 85 articles in both national and international journals. He has presented more than 29 articles in conference proceedings, has been a keynote speaker for various national and international conferences, has been honored as conference chairperson for many workshops and conferences, has been a convener, scientific committee member, organizing secretary for national and international conferences, member of the editorial committee. He has authored 10 books. He had been a President of Mathematics Association, a member of Outreach Program, Industrial Interaction Coordinator. So it's my great honor and pleasure to welcome such a noble personality amidst us. We are blessed to have such a knowledgeable and wisdom-filled person as our keynote speaker. We look forward to your expert talk and presentation. The platform is yours. Over to you, sir.
Thank you, madam. Is it audible? Hello.
Check.
Respected Reverend Sister Secretary, yes, magnificent. Respected Principal, Reverend Sister Pushpam, respected Convener, Reverend Sister Dr. Santiago Teresol, and respected faculty members, scientific committee members, and my dear students and my dear participants. Good afternoon. So it is, I know it's your lunch time. Actually, my time is 11:50 to 1 o'clock. Now it is 1:03. Okay, so hardly I'll take 20 to 25 minutes. So don't worry. So before going into my session, I also would like to share something with you, because on seeing this group, I used to recollect my schooling and college days. Can you guess why? Yen theriyuma? I am also like you from a rural place. My schooling was near Krishnagiri. It is not even in Krishnagiri, that's town, nearby Krishnagiri. Okay, some small village. Up to 11th standard. For 12th, I moved to Krishnagiri. And my college was in Krishnagiri Arts College. Okay, comparing to your college is 10 times better than my college. Just imagine. So, my dear students, you are in a very good space. You are in a very good space. See, right from Krishnagiri, I moved to Loyola College, such a wonderful place. Why can't you to shine throughout the world? It is possible, okay? It is possible, definitely. So with this message, also I would like to share some more things. Actually, after my schooling, I wrote entrance exam in those days for engineering college. Entrance exams was there. And actually, some 35 years back, I got more than 1,000 marks, right? Okay. And I applied engineering, but my father, he was a school headmaster. He strictly said, no engineering, only mathematics. BSc mathematics dhaan padikanum. My father's command. I got engineering. Actually, I got first rank in that +2, right? Yeah, father mathematics padikkanum. My father tried to study mathematics, but he was not able to study. So he forced me, right? Note the, note the word, he forced me to take mathematics. To take mathematics. Actually, in my college days, I used to hate mathematics, right? But even I used to hate chemistry. Now my students are doing research in chemistry, right? So this is the fact. What I'm going to say is, okay, after taking mathematics, I settled in mathematics, and actually in those days, I entered into Loyola College in 1995. At that time, my students, after completing UG, they used to go for IT jobs, right? Okay. One of my students, okay. So one day he came. I was working in evening college, Loyola College, and simply he asked, "Sir, what is your salary?" I said, "My salary it was very low salary at that time." He said, "Sir, my salary is 4 times better than your salary, sir. What is this?" He said. And he also explained for the what are that his job's nature and so many things, right? Okay. Recently, I met him. You can't believe he has developed BP, sugar, and almost all type of diseases. My student, right? எனக்கு அதெல்லாம் கிடையாது இன்னும். That is the beauty of teaching, especially mathematics teaching, right? As I tried to escape from mathematics, my father forced me to do mathematics. Same thing happened yesterday. Actually, I tried to escape from this conference. My sister, my student, he forced, no way, you have to attend the conference. So when sister forcing me at that time, I recollected my father, right? So, thank you, sister, at any rate. Actually, Dr. Jagadish Kumar was talking about practicing mathematician. Okay, see my life, practicing mathematician. Proudly, I can say, I am a practicing mathematician. Practicing mathematician. I am teaching in Loyola College. With that, I cannot say practicing mathematician. Apart from that, I used to write a lot of competitive exam books. Somebody mentioned I have written 10 books. It is not correct. More than 25 books I have written. Actually, have you heard of Sakti Publications? It is for competitive exams. Sakti Publications. In mathematical parts, almost all mathematical parts were written by me. Actually, I am working as a freelancer in that Sakti Publications. It's the leading publications for competitive exams, right? Not only that, see, my origin is from Government Arts College, Krishnagiri. Now, I have taken classes for IIT students, MIT students, NIT students, all type of business school students. And also, now, due to lack of time, I'm taking CSIR net show classes through online. So that's why I might say, probably I can say I'm practicing mathematics here. See, my origin was from Arts College, but I was able to take all type of students, including IIT's topmost students, right? Okay, they used to post problems of all level of difficulty. So we used to sit and we try to solve the problems. Okay, so that is the meaning of practice, right? That is the meaning of practice. Once you start practicing means you can achieve whatever you want. If you want to earn in terms of crores, you can. If you want to go to of the globe, you can. Anything is possible. The only thing is you have to practice. The word practice, it has a lot of meaning. So my dear students, so try to understand. You are a mathematician. Nowadays, everybody is talking about machine learning, right? Machine learning. Machine learning, one golden subject is there. Sir was talking about golden ratio. I can say this subject is a golden subject in mathematics. Can you guess what is that? golden subject in mathematics? Can you guess? It is nothing but linear algebra. Without linear algebra, actually, sir was presenting the whole presentation, no? The whole presentation was based on linear algebra. It is a part of linear algebra, right? It's a golden subject. Linear algebra. Linear algebra leads to matrices and from matrices and other concepts. So, and we can go into the neural networks. If you are good in neural networks, you can work. You no need to go for any company. As a freelancer, you can work and you can earn in terms of pros, because nowadays people are searching for good neural networks to support machine learning and other related things in machine learning. Only mathematicians can do this, right? Okay. So only mathematicians, so with very good knowledge in the linear algebra and very good knowledge in calculus, because neural network means it only supplies the data, how to assign, how to get output in terms of machine learning. That's a neural network. So you, who can deal neural network means it is actually a part of mathematics. It is actually a part of mathematics. The transforms, all type of transforms are used, and even partial differential equations are used in that neural network, right? So if you are good, if you start practicing, means you no need to go to any company. You can work as a freelancer. You can earn in terms of crores. Now, solradhu puriyudha, my dear students? Okay. So the thing is, you have to practice. What do you mean by practice mathematics? In college, in classroom, teachers are teaching mathematics. Okay? Teaching mathematics. Ninga enna pandringa? They will teach, they will cover the syllabus. After that, what you will do? So the brilliant students will cover the whole topics, whatever the teachers covered in the class. Average students select important questions and cover, right? Okay, so this what we try to do, right? This is not practicing, okay? So this is just studying. When the point practicing starts means, suppose you are going to a library and suppose you are referring some book on calculus, or suppose you are start referring something in differential equation or something in linear algebra, what your teacher has not covered, if you start learning that newly, okay, if you are going to start reading or if you are going to learn something newly, means at that time the practicing will start. Okay, so develop this attitude, my dear students. With this, I'll go to my presentation. Actually, my presentation is also based on this linear algebra. So, Sir has explained about the eigenvalues. My starting point is also eigenvalues only. So, can anybody tell me, so from the Sir's presentation, so what do you learn from that eigenvalue concept? Eigenvalue concept, what did you learn from the concept of eigenvalues? Something wrong, right? Okay. Yeah. Eigenvalues? Very good, very good. Actually, I have not prepared proper slides. So one thing I can say, so T is a transform. Actually, transform means eigenvalues means suppose vector is here means so vector is here means eigenvalue. Suppose lambda is greater than means it is enlarged or it is synced, but only in this line. Only in this line. Okay, right? Only in this line. Actually, transform means suppose here you are having some point x means so t of x means it may be anywhere here, right? T of x. So any point can be transformed into some other point, right? But in eigenvalue means so the point is here means it is oscillating or it is moving only in this line, right? Only in this line. Only in this line. Transform means so generally points you are somewhere here means it can move anywhere, right? It can move anywhere. Okay, but the eigenvector moves only along this line. See, I would like to say some practical examples. Now Earth is there. Our Earth. Bhumi irukku. It is rotating. Our Earth is rotating, right? Our Earth is rotating along some axis. Okay, along some axis. So when rotating along the axis, actually what is happening means, suppose a particle is here means, the particle is pulled towards the center. Yes or no? Now, solra puriyada? Earth is there. The axis, along this axis, the Earth is rotating, right? Rotating means some particle is here means it is pulled towards this center. And some particle is here means it is also pulled towards. Okay, so the particle is pulled towards means it's a transform, right? Similarly, everywhere it is pulled towards this center. Yes or no? Right. Now my question is, some particle is here on the axis. Some particle is here on the axis. What will happen to that particle? What will happen to that particle? Can you guess? What will happen to that particle? Nothing will happen. Okay? Nothing will happen. So the transform will not affect. It will oscillate somewhere within this. Okay? So there is no much disturbance for this particle. Okay? Now I give you one more example. You are having in your class, you take some BSc mathematics, third year. Consider the topper, always getting 100 marks. Okay? And some average students. Actually, you are all not average. I believe there is the concept of average. Okay? So for this, to discuss this, I am taking this. Average students getting some 30, 40 marks. Suppose university is giving a kind of tough question paper. Right? The question paper is the transform. Tough question paper. What will happen? And the 40 marks among the students, sometimes what will happen? He or she may get 10 marks, 5 marks, right? Okay. The transform varies, right? But 100 mark getting students, again, he or she will get 100 marks, irrespective of the question paper, right? Okay. So this is one example. 2, 3 examples. From that, what I actually want to say, நீங்க தான் கண்டுபிடிக்கணும். புரியுதா? First example நான் என்ன சொன்னேன்? Earth rotation. Second example, classroom. And I want to say one more example. நம்ம ரேஷன் கடைலாம் பார்த்திருக்கீங்களா? ரேஷன் கடை. அதுல பாத்தீங்கன்னா அரிசி வந்து 1 ரூபாய் கொடுக்குறாங்க. ஓகே? சார் அரிசி குவாலிட்டி இல்லை அப்படிலாம் சொல்லக்கூடாது. It is okay. So 1 rupee. Say in outside market, the price of the rice some 10 rupees or 20 rupees or 30 rupees. Like per kg some 1 kilo arisi evlo ipo 60 rupees. Sometimes tomorrow it may go 70 rupees. Or after 2 weeks or 2 months it may come down to 30 rupees. But நம்ம ரேஷன் கடையில கொடுக்கிற அரிசி 1 ரூபாய்க்கு தான் கொடுப்பாங்க. Okay? 1 ரூபாய்க்கு தான் கொடுக்குறாங்க. So consider these 3 examples. 3 examples. From these 3 examples, what I want to say, what I want to communicate to you. நான் என்ன சொல்ல வரேன்? அந்த 100 மார்க்ஸ் வாங்குற ஸ்டூடெண்ட்ஸ் அவங்க கிட்ட என்ன இருக்குது? Stability is there, right? Stability and consistency. Okay, it is not the external system. It is not he is not disturbed by the transform. Am I correct? Similarly, in the earth axis, consistency is there, stability is there, right? Stability is there. Okay, stability, right? Stability in the axis, the particles on the axis, stability. Similarly, our rice in the ration, 1 rupee rice means stability, right? Okay, so wherever you talk about stability or consistency, you have to talk about eigenvalue. Okay, because the nature of eigenvalue, I told you, it will oscillate only on that line. It will not move. It will not change the direction, right? Change the direction means what? Change the direction means from here, going here. It will not happen. It will oscillate here only. It will not change the direction. That is the stability. That is the stability. Okay. So the eigenvalue concept, wherever you want to study stability, you have to touch the eigenvalues. See, you are constructing bridges, right? Okay, bridges. With more stability, you have to construct. A lot of factors are there. What kind of cement and what kind of structure, what kind of, whether it is parabolic or other, so many things you have to read. Okay, so many factors you can put into a matrix. Matrix is nothing but a transform. From that matrix, you can derive the eigenvalues. Using the eigenvalues, you can construct that is going to be the more stable factors for the bridge. Okay, not only that, you take any social problem. Recently, some 3 years back, COVID, right? Everybody is affected. It is nothing but everybody is affected. But in some, actually, we can see some persons were not affected. Not affected means they are stable. To study also. Okay, so wherever is required, you have to go for eigenvalues. Okay, so that is my message. And so here the stability through eigenvalues, and how to get eigenvalues means you required linear algebra, that knowledge. Okay, so the knowledge, so that's why I told you, so this linear algebra, it is a golden subject, right? It's a golden subject. Okay, so the linear algebra concept, actually practically we cannot apply linear algebra directly, so we consider in terms of matrix. Okay, in terms of matrix, so eigenvalue for square matrix is possible, right? So this one side. Now the graph theory concepts are there. How many of you are aware of graph theory? Graph theory எத்தனை பேருக்கு தெரியும்? Raise your hands, feel free. உங்களை ஒன்றும் கேட்க மாட்டேன், right? Yeah. Actually, see, your college structure is there means your college structure can be considered as a graph. Okay, your principal office is there means it is one point. Your classroom is there means it is one point. Okay, so the entrance is there means it is one point. Okay, so the connectivities are there means connected. From entrance, there is direct road to your class means it is connected. Entrance and the road, your class is connected. There is no direct road means it is not connected. Okay, so to study mathematically, we cannot consider your college directly. Okay, so we required some mathematical format. The mathematical format is supplied by graphs. This is called a graph, right? Okay, so this is called a graph. So our aim is to impose linear algebra on graphs. Okay? linear algebra on graphs. So that field of study is called spectral graph theory, right? Actually, what do you mean by spectrum means collection of eigenvalues, right? Collection of eigenvalues are called spectrums. So actually, graph theory we can study in various point of view. Algebraic graph theory is there. Trying to incorporate group theory in graph theory, that is algebraic graph theory. Topological graph theory is there. Trying to connect topological ideas in graph theory. And chemical graph theory is there. Trying to connect so the chemical structures and studying graph theory, right? So various aspects are there. So here, this is spectral graph theory means connecting linear algebra with graphs. Because linear algebra, I told you, it's a golden subject. So graph theory means it is highly applicable. We can easily model any real life situation. We can model into a graph, right? Okay. So we try to connect linear algebra and graphs. So that is spectral graph theory. Okay. In graphs, we cannot study linear algebra directly into a graph. So the graph should be converted into a what? Into a matrix. Okay. So the graph should be converted into a matrix. So here it is called adjacent matrix, right? Okay. So the points are called vertices and the connections are called edges. So the adjacent matrices, right? Okay. So this is a square matrix. And can you identify anything from this matrix? That's one matrix. Apart from that, so many matrices. What type of matrix is this? எந்த மாதிரியான மேட்ரிக்ஸ் இது? Diagonal matrix. Okay. அப்புறம் okay, unit. Sister is saying all the entries are 1. Very good. Entries are 1, right? Okay. Scalar matrix. சரி சொல்லுங்க, அப்படி சொல்லிட்டே வாங்க. Diagonal. Diagonal. Okay. Diagonal கிடையாது. சரி. One important observation. Actually, this is required as a mathematician. The observation, right? You have to observe, you have to analyze, you have to research in multiple dimensions. பார்த்தோன்னே என்ன தெரியுது? நீங்க மிடில்ல ஒரு மிரர் மாதிரி வச்சிருங்க. மேலையும் கீழையும் பாருங்க எப்படி இருக்கு. Upper part is reflection of upper part is reflection of lower part. What is that? It is called symmetric matrix. No. Symmetric matrix. So this matrix is a symmetric matrix. I think you have studied eigenvalues. This is a question for the PG students. How many PG students are there? Can you raise your hands? PG students முன்னால உட்காரணும், பின்னால போயிட்டாங்க. Okay, this is for the PG students. Eigenvalues in symmetric matrix, real symmetric matrix. இப்ப நீங்க yeah. Okay, no problem. So eigenvalues in real symmetric matrix is always real. So that's the beauty. Eigenvalues in real symmetric matrix is always real. Sometimes you will get complex eigenvalues also. See, for example, you take simple matrix 0, 1, -1, 0. Okay. What are the eigenvalues of this matrix? Characteristic equation is x squared plus 1 equal to 0. X squared plus 1 equal to 0 means what are the roots? X is equal to plus or minus I. Okay. Plus or minus I. Complex roots. For a real matrix, complex eigenvalues are possible. But we should not get complex eigenvalues. If we get complex eigenvalues, we cannot graphically, we cannot imagine. First of all, graphically, we cannot imagine for complex matrices, complex eigenvalues, right? This is adjacency matrix. If you go for spectrum, that is, if you go for value, simply you will get real eigenvalues. You can analyze further through graphs. Okay, you can analyze further through graphs. So the beauty is here, this is the symmetric matrix. Similarly, the matrix. So many things are there. Yeah. So these are the applications of eigenvalues in various fields. So, see, for example, if you take the structural energy, can you read? Eigenvalues helps to analyze the vibration modes and stability in structures. Stability in structures. Over 20 floor building you are constructing means stability is required in terms of earthquake or in terms of other natural disasters. It has to be stable, right? Okay. To analyze the stable in buildings, so we can use eigenvalues. That's what I told you. Wherever the stability and the consistency is required, you can use eigenvalues concept, right? So in economics, you can use electrical engineering, everywhere you can use. And okay, so these are all some graph theoretical terms. So actually, so we have matrix and we have graph. We connected graph with the matrix. So there we are able to get eigenvalues. Okay. And there actually we can go for applications. So, and I how it is applied in chemical graph theory. Okay. So what do you mean by chemical graph theory means? So we are we are having the chemical structures, right? Okay. Chemical structures means we can laboratory we can analyze through experiments. Say, for example, if you want to find boiling points for a structure means some benzoidical structures are there. Some structure you take. Boiling point means you have to do experiments. So you require that particular equipment and the particular lab. In any chemistry lab you cannot do. Okay, particular lab. Also in particular atmosphere, in particular temperature. Okay, so you have to do the experiment. So overall, what happens means to find that single output, you have to spend more than 1 lakh rupees sometimes, right? Okay, so the cost and time consumption. So the thing is that same boiling point we can predict to some extent through mathematical computation. For example, VNR index is there. If the VNR index is high means the boiling point is high. VNR index is low means the boiling point is low. Okay, so that type of indications are there. The computation of VNR index means it is purely a mathematical concept. Purely a mathematical concept. No laboratory is required. No equipment is required. You no need to invest any cost. Simply, you can convert a structure into a graph, and for that graph, you can find VNR index using the definition. So many methods are there. From there, you can predict this structure may have this amount of boiling point or melting point or this kind of elasticity. So many things. So you can analyze through the okay mathematicians. So without going to the laboratory, we can guess the chemical outputs, right? Okay. So that is the usage of that is the objective of chemical graph theory. So chemical graph is doing chemical experiments without going to the laboratory or without spending time in the laboratory, without spending cost in the laboratory. We try to find the output through mathematically, right? So that is the tool used is graphs. Okay, so that's graphs. So various techniques are there. So that concept is called chemical graph theory. Okay, so in chemical graph, try to incorporate. I told you. So eigenvalues are almost applied everywhere. Now the question is it possible to apply eigenvalue concept in chemical graphs? Okay, chemical graphs means in terms of molecules, right? Is it possible to apply? So this man, his name is Ivan Gutman. He successfully applied the concept of eigenvalues, that is the concept of spectrums in chemical graphs, actually in terms of energy, right? Actually, so there are different type of energies are there. It is called pi electron energy, right? Pi electron energy means so different type of bonds are there between the molecules. Sigma bonds, pi bonds, electrons are there. Between the pi bond electrons, the energy transformation, it is called pi electron transformation. Okay, pi electron energy. Between electrons, the transformations in different formations happens. Okay, so it is called pi electron energy. So the Gutman identified that the pi electron energy of a molecule is nothing but, see the last equation. What is that? Last equation is sum of the modulus of eigenvalues. Sum of absolute values of eigenvalues is approximately equal to the pi electron energy between the molecule. Okay. See, find pi electron energy experimentally means it is very difficult. Okay. You require modern equipment, so you have to invest time and different laboratories required, right? But mathematically, this is the formula, simplest formula, right? Actually, it is not accurate formula, approximate epsilon, that's all. Okay. You know, epsilon is very near to, it is a real best approximation. So that's why we are putting equal, right? So this pi electron in the molecule can be derived through eigenvalues. So it is nothing but the sum of the absolute eigenvalues. So these are the finding by Gutman. So for pi electron energy, to find energy, nowadays energies, different type of energies between the molecules are also derived through different type of eigenvalues. Actually, so here we are talking about this eigenvalue alpha k means eigenvalue is derived from the adjacency matrix. Okay, adjacency matrix. So adjacency matrix, it is a basic matrix. Different type of matrices for a graph are there. For example, Laplacian matrix. Okay, so Laplacian matrix, so signed Laplacian, non-signed Laplacian, and even other matrices are there. Okay, so at the end, different type of matrices are there. From different type of matrices, so we can calculate different type of eigenvalues, and nowadays mathematicians, they try to connect with different type of energies with the molecules. Okay, so that research is currently going on. Yeah, so these are some results regarding to eigenvalues. Actually, I thought of deriving see, this is the basic result. Spectral is the basic result. Complete graph Kn is 2n minus 2. And energy of complete bipolar graph is 2 times square root of AB. A is the number of partitions in one, the cardinality of the another partition, right? Okay, I thought of deriving this so that actually mathematician means we are seeing something means only mathematicians can do. Only mathematicians can do. Here in this proof, lot of matrix concepts are there. We are using rank 1 matrix. Can you guess what is the eigenvalue of rank 1 matrix? Anybody? I'll give you a special prize if you say eigenvalues of rank 1 matrix. Rank 1 matrix. Mobile okay? Actually, that concept is applied here in this proof. Okay. So eigenvalue of rank 1 matrix is 0, n minus 1 times. And the last eigenvalue is trace of the matrix. Okay, so go and refer. Similarly, eigenvalue of rank 2 matrix is also there. Eigenvalue of rank 2 matrix is 0, n minus 2 times. Suppose the matrix is n cross n matrix. Okay. So eigenvalues 0 will appear n minus 1 times. And the last two eigenvalue satisfies some conditions. Okay. So this type of results are used. Also, suppose each column of your matrix is equal, sum of each column of your matrix is equal, that sum is also one of the eigenvalues. So many results are there. Okay. So mathematically in linear algebra, almost derived all results are used in the spectral graph to develop the theories. Theories development means, so I am showing some theorems. See, these are all actually developed theories, right? See, this is developed in terms of integral. Directly you can go to the spectrum. You can guess the spectrum. Upper bound is this, lower bound is this. So many results. Actually, we mathematicians derived this. And R of G means the radius of the spectrum. Okay, so I'm not technically. So here these are the applications. Already I have discussed with you. So this is actually a chemical structure. How it is converted into chemical graph means. So this is the chemical graph. What is happening? We are omitting the hydrogen bonds, right? Okay, so hydrogen bonds are, the hydrogens are compressed. So to study the adjacency matrix of the chemical structure, actually this is the chemical structure, no? This is the chemical structure. To derive the chemical structure, if you want to find pi electron energy of the structure, you have to go to this graph. This graph, okay? For this graph, you derive the adjacency matrix. From there, you go to the eigenvalues, add the eigenvalues, it is going to be the electron energy. So this another structure, corresponding chemical graph. So these are the discussions regarding the pi electrons. So almost you are hungry, I know. So I am going to complete, right? Yeah, these are, I told you, so various graph energies. Basically, two matrices are there. What are the matrices? Can you listen? Research is going on different matrices. This is actually called matrix extended adjacency matrix. And the other one is called first Zagreb matrix. The corresponding energies. So it is related with different type of energies. And so this type of different type of matrices are defined and different type of analysis is going on. And this is actually how to work and how to apply the software. So from the chemical structures, we are drawing our usual graph using Hypercam and topology. It is some software. From there, you can construct adjacency matrix. From GAP software, you can construct the energy of the graph. Okay, so different softwares are available. Okay. So linear algebra can be applied anywhere. Now, the developing fields are machine learning, cloud computing, and any computer-related topics. So you can apply eigenvalues everywhere. You can apply. The thing is how to apply. Where you have to apply, right? Enga apply pannu. I told you, where stability is required, there you. So you have to find out. Right? You can start your research, right? So once again, linear algebra is a golden subject. Actually, usually what happens means linear algebra நீங்க என்ன படிப்பீங்க எப்ப group theory, ring theory அதெல்லாம் முடிச்சிட்டு டயர்ட் ஆயிட்டு linear algebra போவீங்க. Group theory, ring theory படிக்கும்போதே உங்களுக்கு சுத்திரும். அதனால வந்து hating linear algebra. No, it is not like that. That is why when student is PG program, first they are studying linear algebra. After that, usual algebra, right? Okay. Thank you very much, students. I thank once again, sister, for giving this chance. I thank the management again. Thank you. Thank you very much. Thank you.
Any queries from the participants? Thank you, sir, for your wonderful and insightful explanation and for sharing your knowledge to lead us high.
Your presentation on spectral graph theory was a very relevant and innovative approach. We gained a lot through your presentation. Thank you, sir. We humbly request you to stay on the podium as we would like to present the certificate and a gift to you.
After the break, all are refreshed to listen to the second talk by Dr. Sabaskar, lecturer, Department of Mathematics, Government Polytechnic College, Arandangi on neural networking. May I call upon Ms. K. Sumitra, Assistant Professor, Department of Mathematics, to introduce our keynote speaker and welcome him for the second day of Icrtmcs 2023.
Participants, distinguished guests, and honored speakers, good morning. We are delighted to have you all here today as we gather for the second day of the ICRT NCS 2023. It's an immense pleasure to extend a warmest welcome to our esteemed invited speaker, Dr. J. Jabaskar, who has graciously joined us to share his knowledge and insights. Your presence truly elevates the quality and significance of this event. Dr. J. Sabaskar completed his PG Mathematics at St. Joseph College, Palayam Kottai, Tirunelveli, his MPhil and PhD at Pondicherry University, Pondicherry. He had cleared in GATE in the year 2009 and CSIR NET in the year 2011. He had worked as an adjunct faculty at NIT Calicut and as an executive engineer, software development at Kennametal India Limited. His area of research is in computational fluid dynamics. He has published various articles in reputed international and national conferences, seminars, and workshops. He has received a few awards and certificates for his academic and research excellence. We are truly honored to have such a simple and well-qualified person amidst us as our keynote speaker. Now, I invite our principal, Sister Pushpa, to honor the speaker with a shawl and the vice principal with memento. Discussions that will unfold today. Let's make this event a memorable one together. The platform is yours, sir.
Online இருக்குதா? Sure. So thank you for your warm welcome. Actually, so first of all, I thank all the conveners of this conference for inviting me for this wonderful event. Am I audible? Okay. So I'm Sabaska. So my lecture is going to be on graph neural network. So actually, this is one of the most active research area in deep learning. Okay. So now, my lecture is going to be somewhat rich in mathematics because I'm from mathematics background. I don't know how many people are from mathematics background, but to follow my lecture, you should know at least some linear algebra things and at least some graph theory also. At least you should know what is graph and linear algebra concept like vector spaces and matrices. I think I assume that everyone have that knowledge. So first, PDF. I close PDF. PDF. So both of these.
இங்க வச்சிடலாம் உங்களுக்கு ஃபிக்ஸ்ட்
இல்ல இருக்கட்டும். கேக்குதா?
கேக்குது மைக்ல கேக்குது.
So my talk is divided into 4 sections. First one is why ML on graphs. So actually, where do these graph structure data arise? How we are going to process that? And by processing these kind of data, what are the information you are going to derive? And the next lecture, so next topic is, next section is AN, artificial neural network from perceptron algorithm. So perceptron algorithm is useful only for the linearly separable data. So, but so we have to extend these linear separable for these perceptron algorithm to the non-linearly separable data, that is through the artificial neural network. So I will give some basic introduction about the artificial neural network from mathematics view of. The next one is convolutional neural network. This is another important variant of neural network, which is specially designed to process the images. So the last or final one is the graph neural network. So here I will discuss how to extend these vanilla neural network to process